All right, awesome. Okay, this is going to be the entire final review. I'm going to work them out from front to finish. I'm not going to do a ton of explaining, so the way I recommend using this video is that you pause it and you work ahead, and you just basically use me as a homework guide. So pause when you're working on a problem, pause it, work ahead, play it, see how I go. And I'll do some minimal explaining what I'm doing as I'm going along. But essentially, at this point in the semester, right, we've gone over all these topics. So you have notes, hopefully, that you have kept track of to go back and aid you in this study session, getting ready for the final exam. So I'm merely going to work the problems out. And I'm going to do it with, this is all the talking I'm going to do at the beginning. I'm going to do it with a bit of brevity. That way the video, because it's going to be quite long, and I will have timestamps in the bottom. So let's get started here. And then hopefully I do see that there's some glare up here. There's not too much I can do about that. I think it'll still be viable. So here we go. Number one, all right? Okay, we'll start right here. One. We've got 3t. 3t minus 5 is equal to 3 minus 5t. 5t. All right. So main idea, all we're doing in that, can you see that? Okay, awesome. Main idea, what we're doing is we're just isolating the variable, correct? All we're doing is trying to get t by itself. You know this at this point. So here we go. We are going to add 5 to both sides. I have 3t is equal to 5, 6, 7, 8 minus 5t. Nice. Okay, now I'm going to move my t over here. We're getting all constants on one side, all variables on the other side. Plus 5t, plus 5t. 5, 6, 7, 8. That is 8t is equal to 8. And then we divide both sides by 8. T is equal to 1. Awesome. Okay, so that is that one. And these are somewhat new markers. Okay, yeah, you can still see it on there. Okay, all right. Number two. Number two is 4x minus 6 equals 3x plus 10. 3x plus 10. All right, and same exact procedure. Exactly the same. X is on one side, constants on the other. We are gonna add 6, add 6. Does it matter if I do 10, add 10 to this side or 6 to that side? It doesn't matter. You just play the rules of the game. Like whatever you do to one side, you do to the other, and as long as you're treating the rules the same, you'll come with the same answer. 4x is equal to 3x. And we add this up, plus a 16. And then I'm going to move my 3 over. 3x minus 3x minus 3x. X is equal to 16. I'm also going to recommend that you do not do calculations in your head. Maybe I'll start writing down here right below that's what I'll do. I'll start writing right below that. I recommend doing calculations on paper, not in your head. Okay, so here we go. We'll do 3. And we have 7x minus 2 is equal to 3x plus 10. 3x plus 10. Here we go. All right. So when you see this, distributive property, we multiply the 7 by that guy, 7 by that guy, and then 7x minus 14 is equal to 3x plus 10. Now this problem looks exactly like the ones that you had before. So same procedure as always. I'm going to move the 14 over. I keep moving the negative numbers over because I like to keep numbers as mostly positive, is why I'm doing that. 7x, 3x. This will be plus 24. We're moving our x's over 7654 gives us a 4x. That cancels, we have a 24. Then we divide both sides by 4. X is equal to 6. And let me also double check my answers. I'm prone to mistakes as well. 1 is good, 16 is good, 6 is good so far. We're on the right track. All right, great. Never be too confident. Be confident, but not too confident in math. Okay, awesome. All right, so there we are on 3. Now, let me not too far over. Okay, cool, we gotta have time. Space for 4. 4. Right here, we have 2t minus 3 is equal to 2t minus 1 plus 4t. Awesome. All right. Okay, it's on the board, so great. Once again, we have this same distributive property. We're going to take care of that by distributing those in. 2t minus 3 is equal to 2t, and then that is a negative 2. 2 times negative 1 plus the 4t. All right, now let's combine like terms, right? Because we actually have a 2t and a 4t on that side. Let's put those guys together. So we're going to have 4, 5, 6. We have 6t minus 2. Great. All right, and we're going to start moving stuff either side. I'm going to move the 2 over to keep this variable positive. You could have gone minus 6 to the other side. It doesn't matter. All right, so we have 3, 6, 5, 4. Keeps a positive 4t. We have this minus 2. We are going to add 2 to both sides. We're going to have, this is negative 1, right? Because 3 is bigger than 2. 4t. And then we are dividing both sides by 4. We have negative 1/4 is equal to t. And that is our answer right there. Number 4, and I think I'm going to start erasing. Great. Awesome. Back over here. And once again, you can always, I don't have to worry about erasing because you can rewind on the video. There we go. So number 5. Number 5, I can start, let's say right here. Number 5. 3p plus 4 over 2 minus 6 is equal to, this one is hard to see on the deal, but I believe it's a minus sign. Let me double check the answer here. 5, it is a minus sign. And then let me mark that in here as well so I can minus. Okay. All right. We have, make sure it's right, copy down right, 3p plus 2 minus 6 equals, cool. And again, I encourage you to pause video, work ahead, and then you can even skip it. If you've got it and you just want to fast forward to the answer, do that. That's all that I'm here for right now. Okay, so we want to eliminate the fraction, or that's how we're going to do it. There's many ways you can do this, right? But we're going to eliminate the fraction. And so what we do is if we multiply both sides by a common denominator, it will eliminate the denominator, okay? And so, and if you ever have trouble finding out, well, what's the least common denominator, you can always just multiply them together and they'll be a part of the same denominator, correct? So let's this one also happens to be the lowest common denominator in this case, so 5 times 2 is going to be 10. So if I multiply this side by 10, I must multiply this side by 10 as well. All right. So then what's happening now is we are distributing this 10. Well, actually, before I do it like this, I'm trying to let me just write it out. I'm going to write the next step out to where it's a little bit clearer, okay? So we're going to say 10 is going to be multiplied by 3p plus 4 over 2 minus 6 is equal to our 1, 3p over 5, 10. Okay, because there is multiplication that's happening here, and there's one thing in the bottom on both, well, this one we have to, here, let's distribute this guy into both right here. So then we have 10, 3p plus 4 minus 10 times 6 is equal to 1 minus 3p over 5. 10. Okay, and that's over 2. All right. Okay, so now we've distributed the 10 to every term. So now, because there's multiplication happening here, and that bottom has one term, we can simplify this. That becomes a 1. This becomes a 5. 10 divided by 2 is 5. It becomes a 1. Over here, the same idea. It becomes a 2. 5 becomes a 1. All right, anything over 1 is itself. So now we can distribute, or here, let me do it step by step so I don't do anything confusing here. Plus 4 minus, we're going to put those together, 60. And we're going to, oh yeah, let me do this before I'm going to put the 2 on this side. There we go. All right, and now we're going to distribute everything in. This 5 goes to each term, 2 goes to each term here. We're going to have 5 times 3 is 15, 5 times 4 is 20, minus 60 equals 2 times 1 is 2, 2 times negative 3 is negative 6p. Great. All right, we've got some like terms to take care of, right? We have constants on this side, put them together. 15p, and then we're going to subtract these two, right? So we should have minus 40, 654, right? For the 60 is bigger, 2 minus 6p. Okay, let me make sure I'm not going now I'm going to add 6p here, both sides, 6p. This guy becomes 21p minus 40 equals 2. I'm going to add, let's see, I'm getting close to the bottom, you can still see. We're going to add the 40 to both sides. All right, this we have 21p minus 40 equals 2. Okay, we're going to add the 40 to both sides. 21p is equal to 42. Then we divide both sides. We get our p, and then this crosses out to a 2, I believe. Yes. We always, while you're going through these homeworks, double check the answer. I'll double check the answer, and then hopefully, it's always good practice anyway, no matter, you know, even if you're sure, don't be too sure, right? Okay, great. That's 5. Let's keep going. 6. I'm gonna go ahead and erase this. Okay. 6. We have x plus 9 plus x equals 3. Great. All right. So on this guy, and once again, I'll try to talk as minimally as possible. We're trying to get these square roots by themselves. X plus 9, and then we have 3 minus x, and we want to get the x's eventually together to find out what they equal. But we got to crack that egg open. The way that we crack this guy open is we have to square it to get, and what you do to one side, you have to do to the other side. So that cancels that off. We have x plus 9 is equal, and then we have these two. This is saying this right now, right? We have this square. That is the same as, this is the same as writing 3 minus x and 3 minus x, right? Because there's two of them. So what we're going to do is FOIL it out and put it in here. So we have x plus 9. And we're going to FOIL this guy out like this, right? First, and it doesn't, the FOIL, the reason why people do that is it just organizes it. You don't have to FOIL, but you can put this term to that one, and then this guy to this one, and that, right? That's all we're doing. So 3 times 3 is 9. 3 times the minus x is a 3 minus x. The 3 times the minus x is a minus 3x, and then we have x squared, right? We've got like terms here. So we have x plus 9 equals 9, and this becomes a minus 6x plus x squared. And then notice here, now we have a quadratic. When we're solving a quadratic, we know that it always is going to be, we set it equal to 0, right? So we're going to move all of this stuff over. And I'm also going to reorganize this. Because this is addition, we can reorganize it to make it look a bit better. So I'm going to, well, I guess let's get everything to one side first, and then we'll reorganize it. So I'm going to say minus 9, and I'm just going to go ahead and actually move everything over, right? And I'm just going to put them under their like terms. So we have a minus x and a minus 9. So if we add those up, that gives us our 0. This gives us a 0. This is a negative 7x, and this is plus, x plus x squared. All right, let's move this over here. We're going to come up here, and we have 0 is equal to negative 7x plus x squared. Great. All right, so that term canceled out. Okay, what's nice about this on our quadratics, because we don't have that constant term anymore, we have a greatest common factor here, don't we? We have x. So we can factor this x out. Do you see how that worked? So I just took the x out of each term, right? And it leaves us with these terms. Now we can set both terms equal to 0. So I'm going to say x is equal to 0, and then negative 7 plus x is equal to 0. And I'm just going to move stuff over. X is already 0, and then if I add that 7 to both sides, it says x is equal to 7. And if you remember, when you have a quadratic, your quadratics, like the number of answers you should get is always associated with the leading power of that polynomial. So when you have an x squared, you know you're going to get 2 x's. If you have an x cubed, you know you're going to have 3 x's, and so on. Double check our answers. This is what, number 6? Number 6, and we're good. Let's keep going. All right. I'll go ahead and move over to this side. There we go. We just finished 6. Okay. All right, so 7. Let's mark it. Make sure I'm not too far off. Okay, we'll kind of this right here. 7. We have u plus 1. I think that's u plus 1 is less than 7u minus 2. Great. All right. Remember, we're always treating, just treat this guy like an equal sign, right? And it only has one exception. It flips when you divide by 1, and that's it. And other than that, you treat it just like an equal sign. So it just flips. It flips if you divide by a -1. Okay, cool. So here we go. We are going to start solving for our u. I'm actually going to move the u over because I just like keeping the variable positive as much as possible. So this gives us a 1 is less than 7, 6. 6u minus 2. We move the 2 over. We get 3 is less than 6u, and then we divide by 6. And then 3 will become a 1, and then 3 can come into that term 2 times, and we have a u. Those cancel out. Had that been a negative 6, if I would have divided by negative 6, it would have flipped that sign. Only difference. That's all you have to know. So we have u is greater than 1/2. What's number 7? Okay, great. Yeah, great. Yeah, and then you'll see in Professor Lucas has just switched this, right? It's u is still on the greater side and 1/2 is still on the smaller side, okay? So you might see just a little organization difference for me while we're going through these problems. Don't let that confuse you. All right, there's this guy here. All right, we are on 8. 8 is 3t minus 2. 3t minus 2 is greater than 10. It looks like I think it's minus 2t and 8. I probably should have gone through here and annotated those so I could see them better. 8. Let me make sure 8 is good. Minus, we're good. Okay. All right. So once again, we're going to go ahead and get rid of that fraction by multiplying everything. I'm going to multiply everything by an 8. And I'm writing it up here, but 8 times this. It's not an exponent. Okay. All right. So if we do that, then we have our 8, 3t minus 2, greater than. These 8's cancel out, and I'm left with this guy. I'm going to distribute the 8 into each term here. We're going to have 24t minus 16. 8 times 2 is 16. 10 minus 2t. And then, man, it's old hat, right? Like everything you've already been doing. So here we go. We're going to add 2t. This will be 4, 5, 6. We have a 26t minus 16 to the 10. We are adding 16 to both sides. Cool. And remember, if you subtract things from both sides, that does not flip that sign. It's only when you divide. That is the only condition if it's division by -1. So don't make that mistake. 26t, and this becomes 26. And then we divide both sides by 26. And then that will leave us with our t is greater than 1. Anything over itself is 1. We get our 1 right there. All right. Okay. Once again, pause the videos when you need to. Pause the videos when you need to. Work ahead. Test yourself. Skip around. This is just completely, to that. That's all we're doing here. We're just crushing problems. 4, we got y. What is that? Y looks like a minus 2. Wait, hold on. 4, oh no, it looks like plus 2 actually. See that it is a little bit blurry on that sheet there. We've got y minus 1 is equal to 5. All right. Okay, awesome. All right, and then, and I'll apologize, I may solve some of these slightly different than what the key is, but I assure you I'm using the same rules. So if things are a little bit out of order, I apologize for that. Okay, so right here we want to get rid of the denominator. Like I had said back in an earlier problem, the most common, the greatest common denominator you can achieve. Sometimes it's not always the greatest one, but you can just multiply the two denominators together, and then you're ensuring that both of them are involved. So this time I'm going to write 1 parentheses, but I'm going to distribute it to everything, and we're going to multiply everything by y plus 2 and y minus 1. That's not off the board. Okay, good. All right, so then if we do that, let me write it, just in case it looks weird to you guys, I'm going to write it down here on both sides. So we're going to have this, and we're going to have this 4 over y plus 2, plus this 2y over y minus 1, equals this 5 plus 2 y minus 1, right? Okay, so now what we're going to do is we're going to take this whole thing and we are going to distribute it just like we would anything else to both terms, okay? And so when we do that, if we multiply this into this terms, you'll see that these two denominators are in common, leaving only these two together. So you're going to end up with a 4 times the y minus 1, and it cancels that out. Nice, we got rid of that denominator. And so now we're going to take the same term, we're moving it over here, and we're going to cancel these two terms, leaving us with a plus 2y, and only being multiplied by this y plus 2. Right on. Okay, and over here, we've got this guy, and we're going to go ahead, you can do it, but it may get a little more confusing. You could put the 5 in there, don't do that. Foil that guy out first. It'll be a little bit more simple. So I'm just going to bring my 5 down, but I'm going to foil this guy out, right? The first, outside, inside, last idea. So we have y times y squared, y times -1, negative y, 2 times y, 2y, 2 times -1, -2. There we go. Awesome. Now let's start cleaning stuff up. Here, we're going to distribute this guy through. Boom and boom. We're going to take this guy here and there. We're going to, guess what? Take this guy. Right? we're gonna do a bunch of distributing. All right. So 4y minus 4 plus 2y squared, right? Because 4 times 4 is what? 4 times -1, -4. 2y times y, 2y squared, 2y times 2, 4y equals, and then we're just going to distribute that 5 through everything. 5y squared minus 5y plus 10y, and then minus 10. And you could have noticed that those were like terms, and you could have already put them together. Do it here, it doesn't matter. All right? So now what we're going to do, like terms, we're going to put I'm going to take all the y's and put those together because that's what I see the most of first, okay? So, and then, I hope this isn't confusing, but I'm going to kind of reorganize with the highest term as we go because it's addition. So plus 2y squared, I'm moving here. 4 and 4 is 8. And then I have my minus 4. Here, we've my leading terms already in the front. Then I'm going to combine these two. That's going to give me a positive 5y. And we have our minus 10. Great. All right. Notice this is a quadratic. These are two quadratics. We want to get everything to one side, combine like terms, set it equal to 0, solve for a quadratic. All right. I'm going to move, and it's always a good idea to have the leading term positive. So, and I'm actually going to do this in one step, right? I'm going to move this whole thing over, subtracting everything here, making this 0, and what I do to one side, I have to do to the other side. And I'm just going to you can do this one by one if you want. I'm going to do it in one step for the sake of time, but I think you understand what I'm doing. So if I add this, 0, 0, 0, we get a 0 here. 5, 4, 3, we get 3y squared. And then 8, 9, 10, I count on my fingers. Yes, even me. And then we have a negative, that should be a -6. I promise through this video you will probably catch me make a small mistake, but that's why we check our answers, okay? All right, so we have this guy right here. Notice, actually, no, we can't do that. I was going to say, if you have something in common with every term, you can divide off that factor. In this case, we can't, even though 3, 2 goes into 6, if I divide by 2, then I'll be left with a fraction. We don't want that. So right here, you can factor it out, or you can use the quadratic equation. Since we're early in the video, and sometimes, like, let's say that whenever there's a leading term right there, it makes the factoring a little bit harder. So what I'm going to do, and what I recommend that you do, is if you get stuck, or if you want to make sure you're going to do it solid, use the quadratic formula. It'll work every single time. It may be a little bit tedious if you're master at factoring through that. So here we go, our quadratic formula, and this will be provided for you on the test. And that's a C, sorry for AC over 2A, okay? And so a good idea is to build it before you put everything in. Perfect. Okay, so now whenever we come down here, we know that our A is going to be our term in front of our leading term. Our B is going to be our term in front of our to the power of one term, and then our C is going to be our -6. Do not forget to carry your signs with you, okay? And those signs are connected to the number. They travel with them, okay? So now we're going to put in, we have our B, our A, and our C term, and then we have our A term. There we go. So if we put everything together, let's clean it up. 2 squared is 4 minus, and then here, I'll probably make mistakes in here. We have a negative and a negative. I always just look and see how many positives or negatives do I have, and I just go ahead and take care of that, right? So I don't have to worry about it. Now all I have to think about is 4 times 3 times 6, okay? So 4 times 3 is 12, and then 12 times 6 is 72, I believe. let me double check, because I'm kind of... please use your calculators when you're going through here. So 4 times 6 times 3. 4 times 6 times 3. 72, great. And also remember to hit multiply and not add if you're don't be too hasty with your calculator. It's easy to make mistakes. Anybody can do math, really. It's like slow down and just make sure that you are thinking about what you're doing while you're going through this, okay? All right. So now we have 4, 5, 6. We have 76 under the square root over 6, okay? And don't forget, I almost forgot to add here, that whatever term you're working with, in this case it's y, your term is equal over here on the outside. Because you're sitting here going, what does that equal to? It equals to the term, the variable, I mean. Okay, all right, so now that we're here, let's see if there is a square root for 76. There isn't. So what we need to do, and remember, this is how we simplify. So we take that 76. Don't worry too much about the square root. And what we're going to do is we're going to just start factoring down. I usually just divide by 2, the lowest one. We know it's going to have an even factor because there's a 6 there. So if we divide by 2, we're going to have a 38. Let's divide that one by 2. This gives us a 2 and a 19. Great. So notice and remember that we have 2 of these guys right there. So it's the same. So now this is the same as writing 2 times 19, right? Well, that 2 and that 2 is the same as saying 2 squared. That's 19. And then you can separate both of those guys like that. 2 squared becomes 2, and then 19. So that's how it comes out of there. I know you can do that a little bit faster, a little bit shorter. I'm just kind of showing those steps really quick. All right? Cool. So here we go. We have a -2 plus or minus. We have this now, square root of 19 over 6. Common denominator, split them up. -2 over 6 plus or minus 2 under the square root of 19 over 6. You know that a 2 and a 6 can cancel down to a 1 and a 3. Negative stays there. The plus or minus here, a 2 and a 6 does exactly what we just did. 1 over 3, leaving us with our square root of 19. You can write the 1 or not. Either way. And let's double check and make sure we have the right answer here. What is this? 9? Oh, I must have done something wrong. Did I add something wrong? 5, 4, 3. Oh, hold on. I've done something wrong here. Hold on. We have our 3, 33 minus 4y. So 2y. We should have had a oh, I did my middle term wrong, you guys. I'm sorry about that. Let's see, I'm 30 minutes in. Okay, like a quick, sorry guys for the mistake. I added incorrectly. Like I said, I'll make mistakes too. And I went a little, like if I'm going really fast as well, which I'm trying to do, I'll need to slow down. Notice right here, guys, 10 and 5, that should have been 5, not 10. So let's go back through here. I'm gonna correct it with my blue marker. So that should be a positive 5. When we add our 8 here, I should have a negative 3. Yeah, sorry you guys, that was my fault. Okay, and so now you actually do, I was hoping to not make too many mistakes through this video, but we are all humans. And also I hope this gives you some confidence. I do a lot of math, so I probably make more mistakes than you do. All right, so now here we do have a common factor. We can divide that guy off. So if we divide everything, we divide everything by 3, that is going to give us 0y squared minus y minus 2. All right, and then hopefully I can cut that part out of the video, you guys. That way I'm not wasting y'all's time. All right, and so when we're here, we can't factor that. I'm gonna kind of move back up over here. I have 0 is equal to y squared minus y minus 2. And if you think about your factors here of 2, we want to be able to multiply to that and add up to a negative 1. If we have a negative 2 and a positive 1, that gives us that. So we can rewrite this guy as a y minus 2 and a y plus 1. Which you can set both equal to 0. And then we have y is equal to 2, y is equal to minus 1. There we go. And then that is 9. That is our answer. I apologize, you guys. There we go. Okay. Now we're going to go to 10. All right. So erase this here. Cool. And then math. Maybe you can think of it like a boxing match or an MMA fight. You make mistakes, you just dust off, you get back in the ring, and you take care of business. Okay. You gotta fight to win. Okay. So 10. Here we go. You're not too far to the side. Okay. 10. Here we go. 10. We have 5 minus 24. 4 over x plus 3 is equal to 1 over x and a 2. What is that? 10 is they're saying that is a negative 2. Okay, there we go. All right. Cool, so we are going to, once again, we're going to get rid of this denominator here by multiplying the entire thing by these guys that are being multiplied. Okay? And so if we do that, and this time I'm not going to write it out in every step since you saw that last one, but we're taking this term and we're taking this term and we're distributing in to every term. That's going to leave us with a 5x plus 3, x minus 2, minus I'm just going to put this in here like this. And then we have our all right, cool. So we see that those guys cancel, those guys cancel. I'm going to FOIL this guy. Every time you see these patterns, first, outside, inside, last. X is x squared. We have a minus 2x plus 3x minus 6. I'm gonna try to go not too fast and make mistakes here. All right, and so then we're left here with a 24x minus 2, and then just our x plus 3. Great. Here, I'm gonna go ahead, and this time I'm gonna combine like terms on the inside here. 3, 2, 1 gives us a plus x here. This gives us a minus 24x plus 4 times 2 is 8, 2 times 2 is 4, and that's positive because those two negatives there. And then we have equals 8 plus 3. There we go. I'm going to distribute this one through here to each term. 5x squared plus 5x minus 5 times 6 is 30, minus 4x, 24, 24x plus 48 equals x plus 3. We're going to combine like terms. And then we have got those guys. That one doesn't show up as well. So we have 5x squared, and then 24 and 5, and just to like, and let when you make a mistake, start changing your habits. Like I tried to do that one in my head earlier, and now I'm going to just add things up in my calculator to make sure that I don't make a silly mistake, which can cost you a letter grade. All right, and then we're back to normal type stuff. We're going to go to, all right, notice once again it's a quadratic. We have to move everything over, have it set to equal, and solve the quadratic. So I'm going to move both of these guys over at the same time. So we have our 5x squared, 19, these are two negatives, so we're going to have 20x, 8, 7, 6, 5, that gives us a plus 15. These guys equal out to 0. And notice that each one has a factor of 5 in it that can be canceled out. I'll try to write my 5s better. So we have x squared minus 4x plus 3 equals 0. Anything 0 divided by anything is 0. All right, and now that we have this, let's see. And we'll do more quadratic. If I can factor it, I'm going to factor it, and then because you'll see some examples of the quadratic formula later. So as we move up here, I should do that with a blue marker, I think. Okay. We can sit here on the side and we can think to ourselves. Let me not take it far off. I'll do it right here. We can think to ourselves. Okay, I want something that multiplies to 3. 3 times 1 is 3, but we want it to add up to the middle term, the negative 4. So then that means that if both of them were negative, then negative and negative give me the positive, and then I can add them up and get my negative 4. So then we can have x minus 1, x minus 3 is equal to 0. And you always double check x and x squared. So minus 3x minus 1x is either minus 4. Negative 3, we already proved that up there. Okay. So then we set each one of these equal to 0. Add 1, add 1, add 3, add 3. X is equal to 1, x is equal to 3. Those are our answers there. This is number 10. Hopefully I didn't make a mistake. Voila, we correct our mistakes, use the calculator. If you're unsure, don't do stuff in your head. Okay, I'm gonna erase this. This is 10. We're trying to go along here, we're at 11. And if I can delete, I'm not sure how good I'm gonna be at editing, but if I can edit out my erasing to make the video shorter, if not, I will put timestamps so you can get through this faster. Okay, here we are. Right here, we're on here, 11. We have x plus 5, absolute values equals 4. There we go. Okay. All right. I'm not gonna. Maybe I'll explain why this happened. I'm just gonna write it how it's done. So when you have this absolute value, what you're saying is that you have the x plus 5 equals 4, and then you have an x plus 5 minus 4. Okay, and then I'll just explain really quick why does that happen. You can rewrite an absolute value sign. You can rewrite it as, and this is only for people who want to know, so don't you can skip this part. I'm just like, if you've been curious and you're kind of like, why does this happen? I'm gonna explain it really quick. You can write an absolute value as the square root of that thing squared, right? Well, and you know when you square something, if you square something and you have, let's say you have negative 2 squared, you know that equals 4. If you have 2 squared, you know that equals 4, right? It doesn't matter if it's plus or minus. So you can rewrite this term in another way where you say, hey, if I do this and I have a negative x plus 5 and I have that whole thing squared, right? Because if I square that negative, it's going to become positive, right? Well, now you know that a square root and a square cancel. Those two things cancel, and we have a negative x. Well, and also too, let me write it like this actually. Well, you know that this could be a plus or minus, right? A plus or minus. It doesn't matter because if we square either one, they get squared. So whenever we cancel this square, we have a plus or minus x plus 5 is equal to 4. And now all I'm doing is just moving that plus or minus to the other side. And so I have a plus or minus 4. You see what I mean? And then that's what allows me to write plus or minus 5 minus 4 and an x plus 5 plus 4. Okay, so that's why that happens like that. If you need those steps in your head, I don't do this every time. I'm just kind of showing you why. Just know that you write one positive and one negative, okay? All right. There we go. I'll try to not do that too often. Okay, so here we go. We got minus 5, x is equal to, this one would end up being a negative 1. Over here, if we say minus 5, x is a negative 9. Your answer should be negative 1 and negative 9. Let's double check, we're here on 11. Great, okay, perfect. Okay, so let's keep going. We have 12. Okay, 12, we have the absolute value, 3x plus 2, absolute value, 6 greater than 6. Okay, all right. So remember here, whenever you divide by a negative, it flips the sign. And so we know that we're going to write both of these guys just like we did here, a 3x plus 2, and we're going to have this 6. But over here, if I write my 6, now if I put the negative in there, that flips this guy around, right? So what we really have here on this side is that. And the reason why it flips was that explanation I did earlier, because you would have to get that negative over there, you're dividing it by a negative, and that's what flips that sign. Okay, here we go. Minus 2, minus 2. 3x, 6, 5, 4. Then over here, I'm going to kind of work them simultaneously. So go down. This becomes a next 6, 7, 8. This guy, 3, 3, 3, and boom. X is greater than or equal to 4 over 3. X is less than or equal to a negative 8 over 3. 12. And we are good. Okay. Great. All right, 13. We have 2x plus 3 is less than 3x plus 5. Okay. This one a little bit easier. Okay. We are getting our variables by themselves. 5, 4, 3, 2. Minus 3. And we're subtracting this 3. We're not dividing it, so it's not flipping that sign. Of a negative x plus 2. Plus 2. We could drop the plus 2 because it's by itself. Now though, this x is negative on this side. We don't want our variable negative, so I have to divide by negative 1, and here comes our rule. When you divide by negative 1, that flips that guy around, and we end up having that. So 13, there we go. All right, 13. We're on 14. And with 14, you know what? I'm going to erase this. And we're going to start 14. Okay. 14. Hopefully the batteries don't run out on this guy. Okay, 14. 3x to the 4 minus 7x to the 3 minus 3x squared minus 7x minus 6 equals 0. All right. Okay, so here, remember that we have to do, when you're not given, if you have 3 terms, like if that guy wasn't there, we could try greatest common factor, right? You can do the double grouping, pull what's out, but we have this extra term right here. So we're gonna have to use another skill, which is gonna be long division or synthetic division. But here, also notice it's not telling us what we need to divide by. So we're going to have to use the rational zeros. So which means that we have the P over the Q thing, right? Which is really it's the constant the constant, and these are the factors over the leading coefficient right here. And remember, there's a plus or minus for these whole things. And so what I mean now is that the P over Q, we're going to have factors of this 6 on top here. So we know that 1, 2, 3, and 6 are all factors. We know in this front one, only 3 and 1 are factors of 3. Okay. So, going on down, 14. I'm going to make sure I don't take a little more. Okay, perfect. Okay. All right, so this, so now, these let's write them out as our terms now. I'll keep it in blue, actually. So that means that we have all of these terms over 1. So you're going to have this. I'm going to put a plus or minus in front, but remember all these terms are plus or minus. We're going to have 1, 2, 3, and 6, because that's 1 over 1, 2 over 1, 3 over 1, 6 over 1. And then we're going to have 1 over 3, 2 over 3, 3 over 3, which is just 1, 6 over 3, which is just 2. All right. And probably for the sake of time, I'm probably going to write down the ones that we need, but let's set this up. So we have long division, and if you remember, all you're taking is your coefficient. So we want the x4 term, the third term, the second term, the first term, and we want our constant. So we want our 3, -7, -3, -3, and then -6. Okay, and now we're choosing one of these guys over here to solve. The problem, the thing that makes it difficult is you just have to test. Start from the first and go on. I'm not going to do that here for the sake of time, so I am just going to choose the ones that work just for the sake of time, guys, because I think we're already almost at an hour. So, so I like that is just something that if you've been practicing in the semester, you'll know. And if you want to, at any point, if you want to see a neat little way to cut that in half at a point in time when you can use a graphing calculator, I can show you that. It's nice. Okay. So anyway, what we're doing in this procedure, though, is we're going to move this first term down. This guy gets moved down. And that is what sets up our dominoes to start knocking them down. The outside is multiplied, and then you place it here. So 3 times 3 is 9. Okay? And then we add down. We add down this way. So 9 minus 7 is going to be a positive 2. And then we multiply the outside. 3 times 2 gives us 6. We add on the inside. That gives us a positive 3. We multiply on the outside. We add down. That gives us a positive 2. We multiply on the outside, add on the inside, and that's going to give us one of those. Okay, so now what's happening is you've divided by, this guy is an x, technically, right? This is our rational zeros. So when we've divided here, we're cutting one of these terms down. These have become to 1 less power. So, so this, I'm going to try to not get into too much detail here, but now we're going to do this second part here. And this is technically x to the third, x squared, x, and our constant now, because we divided one thing off. So now we're going to pick another one. And once again, for the sake of time, I'm just picking the one that works, which Professor Lopez, she chose the last one. So you're going to do a lot of work there. It's good to go through that. Hold on, let me make this longer. It's good practice. Okay, so we have to bring the 3 down, and then we multiply, giving us a -2. We add down, that's 0. We multiply, that gives us 0. We add down 3, and then when we multiply that, those 3's cancel, give us a 2. That's a 0. Now, this was an x to the fourth, that's an x to the third, and now when you did that, that's x squared. When you're at the x squared term, that becomes a quadratic. Guess what? We have to solve it quadratically. So I'm going to rewrite this. We know that's 3x squared plus 0x. You don't have to write that. I'm just doing it to, and we have this guy, and it's and we've set it equal to 0, right? Because it's equal to 0. What's nice, we don't have to worry about this term. And so now we have 3x squared plus 3 equals 0. Move the 3 over. And we have 3x squared is equal to negative 3. And then the way that we take care of this guy, oh wait, hold on, oops, that's me going fast, almost made a mistake. Notice that we can divide this factor out right here, right? You can either go ahead and divide it out, or you could have moved it over, divided by 3, all that kind of stuff. So this will end up giving us x squared plus 1 equals 0. Then we move the 1 over. And that's going to give us x squared equals negative 1. We square root both sides. And that gives us, I'm moving to the right here. Okay. And that gives us, the x cancels out. But then we have this square root of negative 1. And that, by definition, is, oh, and don't forget, whenever you put in a square root, it's always plus or minus. The one that cancels doesn't get the plus or minus, but the other one does. So then this becomes plus or minus I. And remember what I said earlier, the number of answers is going to be determined by the power. You should have 4 answers. So when you get to this part of the problem and you circle that, that's not all the answers, because we had that answer and that answer. So you have to report all your answers. X is equal to 3, negative 2 over 3, I, minus I. And you could also write just plus or minus I there as well if you want. So we got that guy right there. Awesome. Where are we at? 14. Goodness. This is taking longer than I thought it would. All right, let's try to crush these and get through this. All right, you guys. We are now at 15. 15. Let's see here. 15. Sure. X cubed minus 3x squared minus 6x plus 8 equals 0. Okay. Alrighty. Now here, because there's those 4 terms, let's try a greatest common factor first. Let's just see if that works. Squared, and then bring this guy down. And if we bring that guy down, that means that we've factored out of this terms, so that negative 6 is technically no longer negative, and then we pulled that out, a negative out, so a negative makes it a positive. And so we're looking at that. We're going to pull out the greatest factor that we can, which would be an x squared here, leaving us an x and a 3. What's the greatest thing we can pull out of here? That is going to be a 2, leaving with an x and a 4. And unfortunately, that does not. So if you try this in the test and you go through here, these guys have to be the same. So that's not going to work. Which means that we cannot use greatest common factor, and we have to result back to synthetic division and stuff like that. So okay, cool. All right, so once again, we need to, I'm only double checking because there's multiple ways to work some stuff, and I'm just making sure I don't. So we have this guy. Remember, that's the factor here, the 8, which we're going to have 1, 2, 4, and an 8. And luckily, there's only 1 there. These are all plus or minus. So if I write out my terms here, we know that and these are our rational zeros. Rational zeros is going to be plus or minus 1, 2, 4, 8. Great. So then we build our guy up like that. We're taking that, just the numbers here. And then what goes here are our rational zeros. And again, once again, for the sake of time, sorry you guys, but I'm not gonna take you through that struggle bus process. 1 comes down, 1 times 1. You always bring that guy down. 1 times 1 is 1. Then we have a minus 2. That is a minus 2, 6, 7, 8. That becomes a negative 8. And multiply, negative 8, 0. That's supposed to be, oh. Awesome. Okay, now remember this was an x to the 3 squared x and a constant. Well, we divided off one x, so this is in the quadratic form. Once you hit that quadratic form, you want to go to those quadratic methods. So we're going to write this as x minus 8 equals 0. And then we can factor this guy. Once again, use the quadratic form if you don't know how. But we want something that multiplies to a negative 8 but can equal a negative 2. We know that a 4 and a 2 can multiply to the 8, but how can we make sure that that's negative and that that's negative? Well, one of them has to be negative. So negative 4 and positive 2 gives us the negative 8. Negative 4 plus 2 gives us a negative 2. So we can rewrite this guy x minus 4, x plus 2 equals 0. Set both of them equal to 0. We solve for them, we just moving those over, bam. And then remember that before you circle your answer, you're supposed to get 3 answers, right? So you're always like, oh, I got my answers. Do not forget this guy right here. So we have x is 1, 4, negative 2. And 1, 4, and negative 2. And I think, and you'll actually see the answer key doesn't have the 1 in there, but it should be there because that was divided right there. So you should have 3 answers right here. All right, perfect. So that might be a small mistake on the answer key there. Okay, so 15, then we go to 16. I'm gonna have to erase. These problems are getting big enough. I just need to erase right here. I have this big board, but I'm afraid if I move the camera too far back, it's not gonna catch the sound. So here we go. 15. So we have 16 now. 16 is 3x squared plus 7x, cubed. 7x squared plus 5x plus 1 equals 0. Okay. All right, and then once again, I always try, if I see 4 terms, I always try a greatest common factor first. So I'm gonna, well, a 3 and a 7 won't come out. It's not gonna work. So we're gonna have to do, synthetic division and all that kind of stuff. So, and let me remind you, this is your final exam. This is our 3rd synthetic division. Make sure you know how to do the synthetic division. Okay, we have 3, 7, 5, 1. P, Q's, plus or minus, leading term, 1 and 3. This guy is just a 1, which makes that not bad. So we know that our rational zeros, I should have done that in blue. And we have 1 over 1 is 1, 1 over 3 is 1 over 3. This one's not as bad. Well, and it looks like it's probably going to have to be either one of those. 16, let me make sure I don't meander into, yeah, beautiful. Okay, so once again, guys, I'm sorry, I'm going to be taking the answers straight out of here. So we have a negative 1 and a 3. 7, 6, 5, 4 becomes a negative 4. That becomes a 1 and 1, 0. And it is frustrating, but you have to just work through them. You have to test them. That's the only way to do those. Well, there's a calculator way to do it that you'll learn maybe later. Okay, so now, once again, we've divided off one of those x. That's a quadratic now. We have quadratic. Bam. Okay. All right, and then here, there's no factors of 1 that can add up to 4. Now you do have this one. You could factor it when it's right here, but with this, it's a little bit harder factoring. So let's go ahead and use a quadratic formula. It is minus b plus or minus the square root of b squared minus 4ac over 2a. I believe that does factor out, but let's use it this way. You know, if you ever get stuck, the way out is this. The quadratic formula will get you out of the weeds as much as possible. We know that our b is 4, our a is 3, our c is 1, our a is 3. There we go. This is equal to an x. So we have minus 4 plus or minus 4 squared is 16. 4 times 3 is 12. Times 1 is itself over 6. Am I in the way? Okay, you can see. All right, I'm gonna put this over both terms, and then we have 6, 5, 4. So the square root of 4 over 6, and then I'm gonna kind of go this way right here. X. The 4 and the 6 will reduce down, and we have a 2 and a 3, plus or minus. That becomes, the square root of 4 is just 2, so 2 over 6 becomes 1 over 3. You can add these, since it became whenever this actually becomes a perfect square, that means you could have factored it, just so you know. Okay, so then if we add these two guys up, we'd have negative 2 plus 1 gives you negative 1 over 3. Then if we say negative 2 minus 1 gives you negative 3. Negative 3 over 3 is negative 1. And then, and don't forget that you have to have 3 answers. 1, 2, 3, even though that negative 1 is happening twice, that just means there's multiplicity. So you want to write that down again. So your answer is that. Okay, and this is 16. Right. Okay. We've got y squared minus 10y plus 21. Cool, plus 21 equals 0. Okay. Woo, we're back to good old quadratics. Doesn't it feel good? All right. So right here, this one can be factored because we're sitting here thinking, what are factors of positive 21 that's going to give me, add up to a negative 10? And we know that a 7 and a 3, 7 times 3 gives me 21. But if I want to add up to negative 10, 7, 8, 9, 10, beautiful. So you can say y minus 7, y minus 3 equals 0. Set them both equal to 0. Plus 7, plus 3, plus 3. Y equals 7, y equals 3. And remember, you should get 2 answers because your power has a power of 2. Right. Okay, 17, 18. 18 is 3x squared minus 8x equals 3. Okay? All right, so now it's a quadratic. It's got to equal 0. We're going to just move in over the -3, and not a good place to write it right there. But now we have a 3x squared minus 8x minus 3 equals 0. And then here, and this is just me, anytime I see that leading one, I don't feel like factoring, so I just use the quadratic formula when it comes right here. So I'm gonna do that again. Here we go. Cool, and you should have the formula around you at this point in time. I've written it a couple times, so I'll probably quit writing it a little. So no, B goes here. B is our negative, B is our -8. B is our -8. A is 3. And then our C is -3. Okay? So then we have, and that equals X is our term, yeah. So X, 8 plus or minus the square root. 8 times 8 is 64. And then we have 3 times 3, and see there's 2 negatives, so I know it's going to be positive. 3 times 3 is 9. 9 times 4 is 36 over, and then 3 times 2 is 6. I'm going to write this guy out. 8 over 6 plus or minus, I'm going to add these up. 6, 7, 8, 9, 10. 6, 7, 8, 9. Oh, so this becomes square root of 100 over 6. 8 over 6 reduces to 4 over 3 plus or minus, that is the square root of 10 is 10 over 6. Oh. 4 over 3 plus or minus, that becomes a 5, that reduces down to 3. So then when you add these guys up, we have X is equal to 4 and 9 over 3. 9 over 3 is just 3. And then our other one would be 4 minus 5 gives you -1/3. And then that is 17. Yeah. Okay. Nice. That was just a good old, we went back to quadratics after synthetic division. Nice. Okay. That's 18. Okay. All right, 19. 19, where are we on time? Okay. 19. I think we're going to be able to do this. I think it's going to be a 2-hour video. Equals 3 minus 11u. Boom. Nice 11u. Hey, it's quadratic. Set it equal to 0. It's gonna, you're gonna see a lot of that. So I'm gonna move everything over here. I'm gonna move everything over at once. Okay. And actually, I might start cutting the shorthand a little. So we have 4u squared. If I move a -11 over, it becomes a +11. If I move a +3 over, it becomes a -3, equals to 0. And here we are back to our factoring. Let me take you through that. Let's do the AC method actually on this one, because if you haven't used that, so we're gonna use the AC method here on this one. AC method. Okay, so that means that you're taking the A and the C, we're going to multiply those together. So we have the 4 and that -3. We get a -12. Okay? And now, and it's pretty much exactly what we've been doing. You sit here and you go, hey, well, what are multiples that can add up to 11 from here? And you say, and you go, okay, well there's a, that could add up to 11. Let's see. We've got our 1 and our 12, right? Can it add up to 11? Yes, okay. And then what we do now, okay, so is that positive 12? Okay, so -1, positive 12. So now we rewrite this middle term. We split this guy up into those guys. 4u squared, this becomes -1u plus 12u minus 3 equals 0. And now you've created like a greatest common factor type idea. So what we can do now is take the greatest common factor out of that guy. So we would have our, let's do it like this, minus u, and then we're gonna bring that down, 12u minus 3. We're gonna pull the u out, that's the biggest one we can pull out, so we'll have u minus 1. And then right here, we could pull that 3 out, and that would give us 4 minus 1. Do you see what I mean? It kind of comes back. So you we could have done the quadratic formula here for sure. But this is another like nice little deal where you just take the first term, last term, multiply it, find what they equal, then you split the middle term into those two, right? And then you can do greatest common factor. And now we can factor that these guys out here. So I'm gonna actually factor it that way. So we have u plus 3. 4u minus 1 equals 0. Set them both equal to 0. And then u minus 3, 4u equals that. And then we divide the 4 off and you get 1 over 4. -4, -3, great, good. Okay. All right, now we're on 20. 20. All right. Should have brought coffee. Oh my goodness, what was I thinking? Square v squared. I'll drink a lot after this. That's all. Plus 2. Okay. All right. Good old quadratics. It's great. But you'll notice that there's nothing I can factor out of 2 that'll add up to 4. So this one ends up requiring the quadratic formula. And I almost want to do the completing the square on this one to show. Let me look here. Yeah, because okay, let's do that. Because like you can use quadratic formula, but let's complete the square. That way in this video, you'll see quadratic, AC method, and completing the square. Because that one's not used a lot. So I'm going to move this guy over to a -2 here, leaving this space open. And so what we do on the completing the square, we take this 4 and we divide it by 2, which gives us 2. And then we square that. And we add it to both sides to keep the equation the same. So 2 squared is really 4, and over here, we're adding our 4, okay? And so that allows me to write this term as what was inside of here, perfectly squared. And then I add these two guys, 4, 3, 2, and then we have a 2 right there, all right? And so now, and then you can always double check, because it's like having 2 of those terms, b plus 2, b plus 2, v squared, get the 2, 2, 4, 4. Wonderful. That's what the whole completing the square does, is we are able to write this as a perfect square. All right, so now we want to square root both sides. And remember, we're putting that plus or minus in there. This one cancels off. B plus 2 is equal to plus or minus the square root of 2, and then we're going to subtract the 2 over. We have v minus 2 plus or minus the square root of 2. And let me see, 20. Cool, and that's our answer. So I just wanted to show you all, this was the completing the square. This was completing the square method. This is completing the square method. It's nice, it's not bad. People hate this one. No, a lot of people don't use this one. You got to use it when you do circles. So it's a good method though. Okay, great. 20. Okay, 20. But you could have used the quadratic formula, 110%, okay? You can always use that. I just thought it would be nice to see the other method in here as well. That way you kind of get a lot of information in this one video. Because it's already a lot, so let's just stack it on, eh? 21 minus 4x minus 3 equals 0. Okay. Once again, this is let's do let's do a quadratic since I made y'all do the completing the square. But you saw it wasn't that bad, right? It wasn't really bad. Okay. So we're going to build it, and then of course you'll have it on the test so you'll know what's going on here. All right, so we're putting in this is our b, so -4 our b. This guy is our a, this guy's our a, and that one is our c. All right, let's clean it up. We've got 4 plus or minus the square root. For that, the negative becomes positive, that becomes 16. Positive, the two negatives become positive. 4 times 2 is 8. 8 times 3, 24. 2 times 2 is 4. We get here. I like splitting mine up. Let me try to not write too sloppy here. Okay. And then we have the square root. Let's add those. 6, that's 10, 3 to 1, 2, 3, 4, square root of 40. All right, and then over here you want to simplify that 40. I'm trying to get too much in the way. Simplify the 40. So if we have this 40, we know that 2 and 20, 2 and 10, 2 and 5, right? So you can rewrite that guy basically as 2 times 2 times 2 times 5. Those two guys can move out, leaving you with a 2 and a 5. You can't do anything else. So we'll do it as 2 on the square root of 10. So 4 over 1 becomes itself. Over here, you get the 2 square root of 10 over 4. Those reduce, and you get that guy right there. Let's see, 21. Great. Awesome, there we go, 21. The erasing. I really hope I can edit all the erasing out. I'm really sorry that the video's so long. 21, 22. There we go, 22. We're about to venture outside of the quadratics into logarithms. Can y'all feel the energy, the calm before the storm? Can you feel it? X squared plus 3x minus 5 is equal to 0. All right. Okay, so let's see if are there any factors of 5 that can add up to 3? And then you're going to say to yourself, no, we can't. So we got to use one of the methods. Let's quadratic. We've been doing quadratic completing the square. Do you want to see? Okay, y'all saw let's do one more completing the square. I'm sort of like, you see how the quadratic works. Okay, so I'm gonna do, I feel like that's not as beneficial for you guys though. Hey, let's just do quadratic. One completing the square is good enough. Okay, so I have plus or minus the square root squared minus 4, that's our AC over 2A. We're going to fill it in. These are our B's, those are our A's, that's our C's. So B, our A, C. Cool. Equals X. We have minus 3 plus or minus the square root. We got our 9. Minus and the minuses give us positive. 4 times 5 is 20 times 1 is itself over 2. X is equal to minus 3 plus or minus. We're going to have 29 under here over 2. And once again, if we go over here, 29, square root of 29. Yeah. And I also recommend doing that in your calculator. So some people have calculators that reduce, that simplify. Great. You know, if not, you'd come over here and you go 29. You know that a 3 could come out of that. I think that's like, I don't even know. Let's see, 29 divided by 3. Oh no, 20. No, you can't. Hold on. Oh, is that prime? Am I being ridiculous? I think that's prime. So here we go. So I'm going to put this over each term, plus or minus, square root of 29 over 2. And then I think we're stuck here. I don't think there's, because you can't put a 2 into that. I think we're stuck. I think that's good. 22. And we are, I believe this was the form of the answer that was circled here, you know, because there was nothing else that could be reduced. So you can do that, you can put it into the factors if you want. Okay, yeah. Over 2, great. 23. 23, you guys. 23. Okay, we've crossed over the Rubicon. Here we go. 23. 27x is equal to 1/3. We are no longer in the land of quadratics. All right. Okay, so I don't want to confuse anybody. I'm going to take a real simple approach through these logarithms. Refer to your sheet that you have for logarithms, all those sheets. I'm just going to kind of use I'm going to use the logarithms in 3 ways. I'm going to use logs to bring down exponents. I'm going to exponentiate logs to get rid of them, and then I'm going to use the log properties to combine logs if they're plus or minus. Those are the 3 things that I'm going to do with logs, and I hope it's not too confusing when we go through here. Okay, so we need to solve for x. We want to bring the x down. So if I'm going to rewrite this with a little bit of space here. If I say 27x equals 1/3. Okay, I'm going to natural log both sides here. Okay? When you natural log, a natural log lets you take the exponent and bring it into the front. I'm not going to go into detail of how that happens. We'll be here too long. Okay, so that lets me bring the x down. Great. These are just numbers. Don't be frightened. Like, if I was to rewrite this statement generally, and I just said, hey, like 2 times or x times 2, and that was 4 or whatever, right? You would just, and you wanted to get x by itself, you'd go, oh, dude, I'll just divide by 2, right? And get my x by itself, and I'd have x is equal to 2, right? That's what you would do, right? This is no different. These are just numbers. Do the same thing. Like, divide off that right there. X is equal to these. And it's totally fine. If you plug this in, you're going to get a decimal of some kind. If you plug that in, you're going to get some kind of negative decimal there. And then you can just divide those decimals off, okay? So you can go either way. Myself, I'm going to put in, I'm going to actually type this expression to get the answer. And I'll show you what it looks like on my calculator for the natural log of 27. So I've typed it in like this. I like these types of calculators that show the fraction. And when I multiply, I get that negative 1/3. If you did decimals, you're going to see that negative 0.3333, like repeat kind of thing. Okay? Either way is fine. I'm going to kind of go this route, so I hope it's not too confusing, you guys. Okay, so that's 23. 24. 32x equals a. So same exact thing here. I'm gonna kind of space it out so y'all can see what I'm doing here. I'm just applying a natural log to both sides. It's like the same as like I'm multiplying both sides by 10 or whatever. It's like it's very similar to that. And so that allows me to bring that exponent down. And then I'm dividing this guy off. You know, what you do to one side, you do to the other. No different here. Once again, you can go ahead and get the decimal approximations and move that around in your calculator. And once again, I'm just going to take my calculator. And I'm going to get that answer. 3/5. And if you had that answer in a fractional point, that is also equal to 0.6. Not bad. All right. $25. Kind of makes you pretty. These go slow. These go faster than all your quadratic stuff, right? Not terrible. We have log base 2. 2z minus 4 plus a log 2z minus 2 equals 1. Okay. All right. So this is a log property. It's on your sheet where you'll see like log base n plus log base n, and then on the other side you'll see log base, and you'll have that mn together. Okay, so that's what's happening. We're just this is our point of interest. This is what our interesting point right there. That addition. That addition means that you multiply both of them together on the inside. So we have log base 2. We're multiplying this 2z minus 4 and this z minus 2. That's all it is. They look scary, but they are not bad at all. Okay? So, and then when we're on the inside here, this is just normal stuff we've been doing, which is, you know, just your distribution. You know, first outside, inside, last idea, where we have 2z squared minus 4z minus 4z plus 8 equals 1. We have our like terms on the inside. So inside of the log, we're just doing algebra, right? Like normal algebra up in here. So we have 2 squared, we're adding those, minus 8z plus 8 is equal to 1. Okay, well now we want to solve for a z. We know this thing needs to be equal to 0. It doesn't do us any good to just move that 1 over. We got to kind of crack this egg, kind of like square roots. When we're trying to crack, when we get rid of a square root, we square it. It gets rid of the square root. When we get rid of a log, we exponentiate it by the base, okay? And so this might be where my method deviates just a little bit. To me, this seems the simplest. That's why I'm giving you this. However these make sense to you, follow that route. I'm just showing you a way, right? Okay, so what happens is when the bases are the same. Because you know if you have a natural log over here, just as a quick example, if I had a natural log of, let's say, x in there, and it equals like 4, let's say, this people usually grab this. If I exponentiate both sides by e, we know that this e and this natural log are inverses and they cancel, and we're left with this e to the 4 idea, right? Well, why do those cancel? You may have been shown that log, if I put a log here and nothing is there, we know that the base of the log is actually a 10 that's sitting there. What you may not know is that the natural log actually has a base of e that's sitting there. And notice when I exponentiate by the base, it cancels. It is no different here. I'm just exponentiating by the base. If I wanted to get rid of a log 10, I would exponentiate the whole thing by 10 and it would cancel that. Okay? It works that way every time. So this cancels and we're left with a 2z squared minus 8z plus 8 equals 2 to the first power, right? And we know that 2 to the first power is just 2. So we move that over. Or actually, yeah, okay, let's do that. Move that over, minus 8. The minus 2 becomes 8, 7, 6. We get 6 because what I did is 2 to the first power is just 2, and I just minus 2 by both sides, leaving us with 0. Notice we have a factor of 2 and everything. I'm canceling that off. Z squared minus 4z plus 4 equals 0, right? Oh wait, all right. 6 divided by 2 is not 4, okay? That is 3. So always make a mistake sometimes. Okay. Here, it can be factored. You know that there are if I wanted to multiply the 3 but add up to a negative 4, we know it's 1 and 3. Well, if we put both of those negative, we get that 4. Oh, I probably was. Okay. So that means that we can take z minus 1, z minus 3 is equal to 0. So we get a 7 equals 3. I set both of them equal to 0 and move them over. 25. Awesome. Okay, these are your answers. Here we go. All right, we're about to hit, we're get that 2-hour mark, you guys. Let's see, here we go. Twenty-six is log 3 2v plus log 3v is equal to log 3 100 minus log 3 2. Okay, all right. This looks like we're kind of at the end of kind of this big first section with the logs and stuff. Okay, this is no different. Okay, so when logs are being added, logs are being subtracted, we're just gluing them together through multiplication through division. That's it. So we have log 3 and we have 2v times v, and here we have log 3 and we have this division. The first one always goes on top and the second one goes on bottom. Just combining them, right? And then you can either logic this or you can use, I'm going to use, so if these two are equal, then the insides must be equal. However, I'm going to go ahead and say, hey, if I exponentiate both sides by this base 3, that's what cancels those things out, and we're just left with 2v and 100 over 2. This is v squared. that becomes 50. We're dividing by 2. That gives us 25. And then we're taking the square root which gives you a plus or minus 5. Bam. This is 26. Cool. All right. Let's see. Awesome. That is up to 26. Let me see, where are we at on time? Oh, we're good. Oh no, it's 1. Oh no, that clock's wrong. 12. We're good. Let's keep going, guys. 27. 27. Okay. Evaluating. So we have this h of x is equal to 2x plus 1. There it is. Okay. And then we're over here, we're saying h0, h minus 1, h3. Okay. It's saying evaluate. It's basically saying, hey, put those numbers in here, plug it in, solve. So if we put in h of 0 in there, we're just replacing wherever the x is with a 0. The h of 0, 2 times 0 is 0 plus 1. We just get 1. Okay, then we're going to take the h minus 1. We're going to put that negative 1 wherever we see, not ln, but h. Becomes negative 2 plus 1. So it becomes negative 1. Over here we have h to the third, right, not to the third, but in the function. Put that in there. 2 times 3, 6 plus 1, 7. I keep writing my h, we just did natural log of h is like a natural log. We have that. Nice. That's all that is. You're just plugging it in. Plug it in. 28. We've got g of x is equal to x squared minus 2. I think that's what that says. And then it says g of 2 and g of negative 2. Okay. Let me make sure that that is 26. Or no, 28, sorry. That is a square. Okay. All right. So we're just plugging it in. 2. So we're going to put a 2 where the x is. 2 squared is 4 minus 2. 4, 3, 2 gives us that answer. Then we have g of 2, or sorry, g of negative 2 in this next one. And we just put in a negative 2 where the x is. And many points you've seen in the past, a negative number squared is just positive. 4 minus 2. Four, 3, 2, 2. Great. Awesome. Okay. 28. 28. 29. 29 function 1 over, wait, 1, is that 1, x minus 3 is what it says. I believe, let me double check. 29 is 29, it is a minus 3, okay. And then all it's asking us here is we're finding domain, okay? So we are, it's saying like, or what is the domain, okay? So the way that the all domain is telling you is it's asking you, hey, how far left and how far right is a function going out. So if you're imagining your xy, we're literally saying like, hey, how far in this direction, how far in that direction are we going? That's all really domain is. It's like, how far in the x direction are we going? So the other thing we need to know is that you cannot divide by 0 in, you cannot divide by 0. It's undefined. So if we take this denominator kind of out of context and we say, hey, if that was equal to 0, then that means that x would equal 3, and we don't want that, right? So you would write your domain. You'd say, hey, my domain is, it's always all real numbers. We want as many real numbers in our domain as possible, but we found an exception because if I put 3 in here, 3 minus 3 is 0. We don't want that. So we want all reals except x equals 3. We don't want that. So that is our domain. All reals except, okay, and then 30. Okay, you can see 30 is f of x is equal to the square root of 2x minus 5. Okay, cool. All right, so in this same kind of idea, we want real numbers, right? And you know that if you have a negative number, if you have a negative under a square root, it means it's an imaginary number if you get a negative under a square root. So we want to avoid that in domain. So what we do is we take our 2x minus 5 and we say, hey, wouldn't it be nice if everything was greater than 0? But remember too that the square root of 0, if I plug the square root of 0 into my calculator, I get 0. That's a real number. That's not imaginary. So we want to include 0 in everything greater than 0. So then if we solve this like normal, 2x, and I'm subtracting 5, I'm not dividing by 5, and then we divide by 2, 5, 2, then we're saying down here, we're saying, hey, our domain, we say it's all reals, and then we say such that our x value has to be greater than or equal to 5 over 2. And if you put 5 over 2 in here, the 2's cancel, and then you have 5 minus 5, that's 0. And then so anything greater than that number gives you a positive value. And then so real quick, if you were to have to draw this on a number line, you put your 5 over 2, you would color it in, and you'd say, hey, it's all of these guys, right? And over on this one, you'd have your 3, and it just wouldn't have the 3, and you'd say, hey, it's all of these guys and all of these guys. So that's, if you have to color them in, that's how you would kind of do it on another line. All right, great. That's domain, you guys. Okay, and then really quick, if you get a regular polynomial or whatever, and you're asking like, and that's an F of that. I'm starting to write sloppy. You can put any number in those x's. So these polynomials will be all reals every time. Okay. But don't confuse that with if that polynomial was over 1 and that thing that I just wrote was there, you still can't divide by 0. So you would actually have to solve that thing, find the zeros, and it would be all reals except whatever zeros you found. So don't get confused. If you see those mixed, you have to treat them appropriately. Okay, so now we're going to 31. And we have x plus y equals 1. And then we have x minus 2y is equal to minus 8. All right. Let me see, where are we here on time? Okay, we're almost at the 2-hour mark here. All right. Solve by elimination, substitution, Kramer's rule, and matrix elimination. Okay, and I'm thinking that Professor Lopez is wanting. Let me double check something here where we're. Okay, we're not. It's 31. Okay, I see. Okay. She doesn't mean to solve that one by all of those rules, but to pick one of those rules to solve by. All right. So if we're solving, this is a system of equations now, and so what we're wanting to do is eliminate a variable. So different ways you can go about it. I really like the method where we add them. I like that a lot. You can solve for one of these variables, like move the y over, and then plug that in here and solve. That's a way. But I'm gonna do it through the addition kind of thing. All right. So if I multiply, let's say this term by a negative, this whole thing by a negative, then that means that I have x plus y minus 1, and then I have a negative x, positive 2y, and then that negative becomes a positive 8. Now, if I add those down, it eliminates, this is the elimination method, it eliminates that 0. We have plus 3y, 8, 9, we get 9. So then I can solve this guy out, 3y, 9. I can divide by 3, and we have y equals 3. All right, so we have our y. Now we can go back in and plug it into either one. I'm gonna pick the simpler one, and I'm gonna say x plus 3 equals 1. X, I'm going to subtract the 3. It's going to give me minus 2. And so then I can say that my x and my y are minus 2 and 3 to solve our equation here. 31. Awesome. Okay, so that's the system. The elimination method is nice. Okay. All right, 32. 32 is 6x minus 5y equals 10. 9x minus 4y equals minus 13. Okay, I'm going to take the same exact process that I did earlier. So I'm going to, I'm going to get rid of the y's is what I'm going to do. So if I multiply, I want this one, I'm going to keep this one negative and I'm going to make that one positive. 5 times 4 is 20. That's like their close relative, you can think. So if I multiply this by 20 and this by 20, and there's many ways to go, then what I'm going to get is 20 times 6 gives me my 120x. Or sorry, hold on. Oops, I almost made. We want 20. We don't multiply by 20. Sorry, almost made a mistake here. We want to multiply this one by 4, and this one by 5, and I'm going to make that one negative, so we change that sign there. And then that will give us 20. There. So if we say 4 times 6, we're going to have negative 24x, and then this negative and negative goes positive, gives us a 20y, and then this will give us a negative 40, and then this one right here, 5 times 9 is 45, and this will give us a negative 20y, and then 5 times 13, I'm terrible with that, we have a negative 65. Okay, so let's make sure we switch our signs. So all these signs should be opposite, great, because we put a negative. These signs should be the same, we're good. Let's add down. So 45 minus 24, this gives us a 21x. This eliminates, nice. Well, I'm gonna put a 0, and then here we have minus 40 minus 65. Gives us a 105, negative there, okay? And so now, I hope I haven't been standing in front of these, okay, anyway. Minus the 20, or divided by the 21, x, and then I'm not sure if that has it does, okay, negative 5, awesome. So we found our x, and we just go back up there and substitute it into something. So I'm just gonna take this outward. So we're gonna have 6, we're gonna put our negative 5 in there, equals 10, and we're gonna solve for y now. So we have, this is negative 30, minus 5y equals 10. We're gonna add the 30. If we add the 30 there, we get 40. We're gonna divide by the negative 5, right? And then we have, I'm sorry, I'm starting to get tired, so I'm gonna start dividing. We have negative 8, negative 8, and then there we go. And so then our x and our y answer is negative 5 and a negative 8. There we go. Awesome. Solid. Okay, so we're at 32. Okay. All right, and then we're at 33. Okay, 33 is going to be 2x minus 4y equals 6. Then we have 3x minus 6y is equal to 9. All right, we're going to, I'm going to continue using elimination. And so I'm gonna choose the y's, and we know that the closest one that they're related to is 12. Actually, you can use 12. So I'm gonna keep this one negative. So I'm just gonna multiply this one by 2, and I'm gonna multiply this one by a negative 3, so I can get these signs to form. So I put a negative 3 in here, you get negative 6x, a positive 12y, a negative 18. Here we get our 6x, we get our negative 12y, we get our 18 right there, okay? So then when we add these guys up, oh no, look what happens. 0, 0, 0, no, okay. 0 equals 0 is actually, it's a true statement, right? So what this actually, you can infer from this problem is that there are infinite solutions. Infinite solutions. So if you have infinite solutions, then what you have is you have dependency. And what we want to do now is to, we need to kind of build our formula downwards and get okay, so I guess what I'm trying to say is you have an infinite solution, so it's going to be dependent on a variable. It's going to be dependent on the y variable. The last variable is how we're going to kind of do these. And so that means that if I solve for my x in terms of y, so we have a 2x minus 4y equals 6. And we, because basically also what this 0, 0 means, it means y equals y. That's also what that means. So if we solve this here, and we say, I move that 4 over, we have 2x and all this, and then I divide off by my 2's, x. So 6 divided by, let me write it over each term so that it doesn't look confusing. So 6 divided by 2 is 3, 4 divided by 2 is 2, and so now our x is dependent on this formula, and we can say that our solution is 3 plus 2y, y. Oh, she solved it for the other one. Oh no, I'm sorry, you guys. Okay, so she solved it for, so we could have said x equals x here as well. And then it would be dependent on the other one. I chose the other variable, so that's my bad. I typically choose the last variable, but we could have easily solved this. Let me do it her way as well really quick. So if we have 2x minus 4y equals 6, let's solve, let's make x the dependent variable and the other one will depend on it. So that means that we would have minus 4, you can see that, right? Yeah, okay, minus 4y equals 6 minus 2x. We would divide off this negative 4. Y is equal to, this is a negative, that is 3 over 2, and this becomes a positive 1/2 x, and I believe that's what she has. Yes. So then the other, because this is still correct, but the other form of the answer could be written like our xy, and then we could say, hey, our x is our dependent variable, and then our y would be our 1/2 x minus 3 over 2. Okay, and so here's just an example of, both of these are correct. Both of these solve the system. It's just depending on if your y is going to be dependent, or sorry, the independent variable, and your other one depends on that one. So there's two forms of that answer right there. So if you went that way like I did, there we go. So there's that one, 33. No, we're at 34. Actually, I think we're over the 2-hour mark. Oh my goodness. Okay, 34. We have y minus 2z plus w equals 5. 3y minus 2z minus, minus 2z minus 2w minus 13, 2y minus z plus 3w and 11. All right. And then let's see, I want to use, let me use Professor Lopez's way here. Okay, I may not go the exact same way, but I'll solve it with So we're going to go through this process. We have to solve this equation here. This is where we do the pivot stuff, if y'all remember. We're going to pivot and do all that. So let's just say that I'm going to use this as my pivot. We're going to pivot off this guy. So my pivot is going to come down here unchanged, right? I'm going to kind of box this stuff out here. Okay, my pivot's going to come down here unchanged. And then what I'm going to do is eliminate my y, and we're going to have this, we're going to try to form this triangular shape as we eliminate certain variables to where we have one variable left, we plug it back in. I think of it as like stacking cups, and we solve the rest of these right here. So, this is only my notation, but I'm going to end up calling this one row 1, row 2, and row 3. Okay? And that's just for me to keep track of stuff, so don't worry about that as much. So we're going to go through here and eliminate, and I'm going to say, hey, what if I take my first row and I multiply it by -3? And I say, hey, row 1, and then I'm going to add it to this row, right? Okay, and this is just my notation. Don't worry about it too much. So if I take a -3 and I multiply it by here, I'll have a -3y. That negative will make a positive, and I say -3 times this, a positive 6. -3 times this, so -3 is this. And then I'm just going to put my second row in there. Okay? We just put that in there, and then I'm going to eliminate. This eliminates, right? And then 6, 5, 4. And then we have a 3, 4, 5. And then we add these guys together, 5, 6, 7, 8, and 2. So we have that. Right? So now I'm going to put this guy in here. Okay, cool. And now we're going to transform this other one. And so I'm going to say, hey, what if I take -2 and I multiply it by my first row, and we add it to that third row there? You know what, I'm going to do this in blue on this. I'm going to do the side calculation in blue. That's my bad. Might be easier to look at or to track. So if I multiply -2 by this, we have -2y, positive 4z, -2w, and then a -2 gives me a -10, and then I'm going to put my third row in there, 2y minus z, sorry if I'm in front of it, plus 3w equals 11. I'm kind of in front of it, 11. Okay. All right, so we're going to add these guys up. This eliminates 4, 3, positive 3z. 3, 2, 1 gives me a positive w, and then that gives me a 1. So I'm going to put this guy in here, right? Okay. So this is our little like first transformation. Don't really worry about it, but like we transformed once. We want to do one more transformation to eliminate, so we can have this single variable, so then we can go back through in reverse and solve everything. So now we don't really care about this one. We want to look here and we want to pick a pivot, and I'm gonna pick this one. You know, it's really kind of arbitrary. Okay, and so now what I'm gonna say is, what if I take, this is my second row. I want to keep it the same, and I actually want to say, hey, why don't I multiply 5 by this one, because it'll, or actually, no, hold on, I want to keep my w's actually. I'm going to be kind of a little bit particular I want to keep the last variable is what I'm going to do. You could eliminate that, but let's say I eliminate this z, then I'm going to keep the last variable. It'll just make it nice and triangular is why I'm going to do that. Okay. So this closest relationship is by 12. So So if I make this one a 12 and that one a 12 and put a subtraction on one of them, I'll eliminate it. So let's say I take, and I'm going to keep the top one positive, and I'm going to say I'm going to multiply 3 by row 2, and then I'm going to add it, and then I'm going to actually multiply -4 by row 3. Okay, and this is just me like keeping track of what I'm doing. So if I multiply this by 3, I get 12z. And I multiply by 3, -15w. Multiply by 3, I don't know what that is, I'll have to look. So 8 times 3 is 24 with a 2, 3, 6, 7, 8. Is that 80? -84? Yeah. Okay. And then I'm going to multiply a -4 by this one, which is going to give me a -12z, and then I'll multiply by a -4, sorry, a -4w, and then a -4 like this. Okay, that eliminates this one. We have a -19w, and then we have a -88. Okay, so then I'm going to solve for my w here. If we divide both sides by -19, that gives us that'll end up giving us a fraction, which is okay. I'm just going to double check here and see which way. See 34. So we did, well, did I add something incorrect? Did I make another mistake? Hold on. Let me make sure I didn't make a mistake here real quick. So I multiplied -3. We just wrote this one down. We added 0, 6, 4. Then we have a -5, right? 5, 6, 7, 8 to -28. We put it in here. Good. And we transform this other line, and we multiply by -2 for the top one. 4, -2, 2, right? And then we took our bottom one. We add across 0. That's 3. 2, 1. That's 1. 11 is 1. Put that in there, okay? And then we were finding out for z, if I multiply this by 3, 3, 3, I did that. Okay. And then we did by 4, a -4, it was negative. 4, -4, that should be right. And I had something wrong. Team. Okay. So we have, and oh, sorry guys, like I think I let me look at her answers, because she kept that. See, we're solving the system the right way, but we're getting one second, you guys. Sorry, I'm going to do a matrix real quick and solve this and make sure that our answers are correct. Hold on. And I may show y'all what I'm doing, that way you can see some neat stuff in the future. And then we have it 2, -1, 3, and then -11. I don't want to mention it, but I think there might be a mistake on the answer key here, because our answers are matching up, and I just kind of want to prove to you really quick. I may have to get in contact with Professor Lopez. 34's answer key is wrong, actually. So let me show you what's happening here as proof. Okay, so later on you're going to learn some graphing calculator stuff. Okay, so really quick, you have a matrix button here on a graphing calculator, okay? And so if you hit second and you can go into and you can build a matrix. Okay, so I'm making a 3x4 matrix, and so I'm entering these numbers in 1, -2, 1, and then it'll be -5. Imagine I move the 5 over and it's negative. Okay, so notice here that we have a 1, -2, 1, -5, 3, -2, -2, and a 13, because we're moving it over on the other side of the equal sign. We have a 2, a -1, a 3, and a -11. And so what you can do is you can hit this, you can, in your calculator, I didn't know you could, oh, cool. I didn't know you could change the, like, so if you go into second and matrix, you can scroll over here to this math button, and you can actually come down here to this thing called reduced row echelon form. That's actually what we're doing. We're doing a reduced row echelon form, okay? And so whenever I select, here, let's actually do the calculation. So if I come here and I select it, reduced row echelon form, and then I choose the matrix that I made, which was A, and then I'm gonna make sure that they are fractions whenever I give it. And whenever I do that, our calculation actually gives us some complicated fractions. So the answer to this problem is actually this right here. The answers are actually, our answer is actually y is equal to a -39/19, and x is a -23/19, and our yz, and then our w is actually an 88/19, which is what we were getting over here. So if you were on the homework and you were having a very difficult time with this one, there's probably like a small numerical error in here that made those work out a certain way. I might have copied it down wrong. Let me see, is this 34? Did I write something down wrong? We have y minus 2, 1, 5, 3. Oh, that's a positive. Okay, my bad. That is okay, that's why we got those crazy answers. We're still doing the right procedure. If that was, okay, I'm so sorry. This should be positive. That should be a positive. Okay, so that is my mistake, you guys. I'm sorry, we're almost on a 2.5 hour deal. I copied the problem down wrong. So that is my fault. I copied the problem down wrong. So let's back up and actually, so that's my second major mistake in the video. You got to make sure you copy your problems down right. Okay, so hold on really quick. We're going to do the same thing. And we are going to make sure that our number, we do the problem the right way. Okay. Alrighty, so this is going to be a positive 2, you guys. All right, but the same thing stands here as I'm multiplying by a negative because I want to eliminate this. We get 0, 6, 7, 8. We get 8z, and then minus 5w, and this is our minus 28 there. All right, so that comes back in here. 8z minus 5w equals minus 28. Okay, then we want to transform our next one where everything is pretty much going to stay the same, where I said negative 2 times our row 1, and we're going to add it to our row 3. Okay, and so that'll be a negative 2y, a positive 4z, and then a negative 2w, and then minus 10. And then we'll write in our correct stuff. All right, this one is 0, 3z, positive w, and a 1. We're going to put that guy in here, 3z plus w, 1. Okay, now we want to choose a pivot. I'm going to eliminate these two guys. I want to keep the w, same idea. Their closest relative is at 24. 8 times 2 is 18. 16. Yeah, so we're just going to do 24. Okay, so I'm going to use this as my pivot. We're going to come down here and I'm going to say, hey, I'm going to take this row 2 and I'm going to multiply it by 3. I'm going to add it to, and then I'm going to multiply this guy by 8. But I'm actually going to multiply it by a negative 8 by our third row. Oh, so I'm kind of in the way here. All right, so here we go. That makes it 24z, and then 3 times this is a minus 15w, and then by 3, was that our, oh my 3, just use our calculator. Negative 28 times 3, yes, that was our 84 we did earlier. And then we're gonna put this guy in here, negative 24z, then a negative 8w, and a negative 8. Okay, and we're going to add these guys together. We have 0 minus, I hope I haven't been in front of the camera the whole time, oh my goodness, 8, 9, 10, 11, 12, 13, 8, 9, 10, 11, 12, I'm sorry, I'm getting tired, you guys. Let me make sure I'm adding everything right. 23, and then negative 84 minus 8, negative 92. There we go. And I'm going to go ahead and divide that off. So negative 92 divided by our negative 23 gives us 4. So I'm just dividing this off there. So we got our 4. So our next transformation, our pivots come down unchanged. Our 2 pivots, and then our new solution there, we got w equals 4. All right, and so then we just work in reverse. We plug this guy in here and we solve backwards. So if I take my 8z minus 5 and I plug in that 4, it's minus 28. Then we have a negative 28. We're adding our 20 to both sides. And then we have negative 8. And then when we divide both sides by that z, we get a negative 1. Okay. And then now we have a z and a w that we can plug in this one. up here. And so I'll kind of, I'm just gonna work it over here on this side. So if y is equal to 2, z is -1, w is 4, and we have 5 here. All right, so then we have y, this is positive 2 plus 4 equals 5, plus we have plus 6 equals 5, y, and then we subtract that over there, which gives us a -1. So our full answer, if we put them all together, would be our y, z, w is equal to, y is -1, z is -1, w is 4. Awesome. All right, guys. So this is, I'm probably just going to keep all these mistakes in the video because it's just a, it just goes to show you, hey, like, hey, I wrote down, when I copied the problem down, I copied it down wrong. I probably was looking at that again when I wrote it down. So let that be a lesson to you, right? Be very careful when you're transcribing your problems because you can end up making a gigantic mistake. And especially on a problem like this, you see how much work that these go into. So try to avoid those mistakes. And then you'll probably be upset to know that you could just solve them with a calculator real quick. So instead of doing, you're going to be like, why did we have to do these by hand? But they're good to do. Okay, awesome. That was 34. Okay. Here we go. And then 35. Let's not make a mistake copying down our problem. 35. X plus y minus z is equal to 3. 2x minus y plus z equals 0. 2x plus y plus 3z is equal to 0. Okay. It may not be a bad idea. Second glance, y(x) minus z, 3, 2x minus y plus z, 3x. So when you make a mistake, change your habits. You know what I mean? Reinforce it. I make mistakes, everybody makes mistakes. Okay, here we go. I'm going to do the same thing where I'm going to choose my pivot. I'm just going to arbitrarily choose this as my pivot. And so I'm going to come over here and I'm going to say, I'm going to multiply a -2 by my row 1, and I'm going to add it to my row 2. Which means that I'm saying -2x, -2y, positive 2z, -6. And I'm going to just take this second row here. We're going to add these guys up. This is 0 minus 3y plus 3z minus 6. All right. We take our first transformation. What we just found. Okay. All right. And now we're going to transform our next one. I'm going to do the same thing. I'm going to take a -2. I'm multiplying it by this row 1, and I'm adding it to this row 3. So we have this exact expression, so I'm just going to copy that one. 6. Okay, and then we're taking this one, and it's 2x plus y. Oh, sorry, no, yeah, we're just adding it in there. That's right. We're just copying it down. 0. Adding this guy, that's 0. We get a negative y plus 5. For adding minus 6. So we're going to plug this guy back in over here. All right. Let's make sure I added things right. -3, 3, 6, 0, 2, -1, 5, 6. Okay, So now we have this transformation. All right, so I'm gonna pivot off of, I'm just gonna pivot off of this guy. And we're gonna say, and we're gonna go, I'm just gonna take my row 1, 2, it's this guy, and I'm actually gonna multiply by a -3 to make that positive. By the way here. And then so I'm gonna say, I'm gonna add it and I'm gonna multiply a -3 by this row, this third row. So just copying down that one, -3y plus 3z equals -6. And then the -3 here makes it a positive y, -3 makes that 18, and then a -3 makes this a positive 18. Okay, so when you add this together, 0. This gives us a -5, 4, 3, 2, -12. This is 12. Okay, so then when we divide that off, that gives us a -1 because we're dividing it by a -12. Okay, so now we take our pivots, our 2 pivots, and then our guy that we found here, z is equal to -1. That's that guy. And so then we just plug it back in and find everything. So we have -3y plus 3, -1 equals -6, -3y minus 3 equals -6, plus 3 plus 3, -3y is equal to 6, 5, 4, 3. It's a -3. And then we have y is 1 because we divided both by negatives. And then I'm going to take my z and my y, plug it in the first one, x plus, and our y is a 1, minus 1 is our z, I'm kind of in the way, and equals 3. So then we have x, 1 plus 1 is 2, and then we subtract the 2, and we get 1. So our answer is just right here to our x, y, z is equal to, we got x is 1, y, sorry for being a little disorganized, and -1. That should be our answer right there, you guys. Still check. 35. Great. So we're good. No mistakes this time. All right. Okay. Verse 35. Let me see. We are here on. See, how many more do we have? 35. We're close. Just at 35. Okay, we're close. Stay strong, everybody. This is 2.5 hours. Stay strong. 36. Okay, 36 is going to be, we're doing a determinant, which is 1 minus 2 minus 3, 2, 1, 4, 4, 0, -1, boom. This is a determinant. And you can just solve these on a calculator, but we're going to do it by hand. Okay, so what we're doing is it's kind of like a basket weave or a diagonal. So what we can do is we're going to write out this column and this column here. You can there's this basket weaving technique, there's all these techniques. I'm extending it out so our diagonals are easy to see. And let me use this. So I'm gonna multiply these guys together in this first one here. So we're gonna say 1 times 1 times negative 1. So let me write it like this, I guess. Right? And then we're gonna add, and we're gonna say negative 2 times 4 times 4, right? We're doing that. And then we have, and we're adding that to a negative 3, 2, and a 0, right? Okay, so that's that first one. Then we have to, let me see if I don't run out of space. Okay, then we're going to subtract it from the other direction, and I'll use a different color. Let's use this purple one. Okay, so now we're going down this other diagonal in this direction. So I'm saying, and over here I'm saying negative 3 times 1 times 4. You can write it like that maybe. Okay, and then we're adding it. Oh, use this other color. Coming down this way. And anything times 0 is 0. So if there's a 0 there, I'm just going to cut a little time out here. I'll throw a 0 there. You can see that that one's also 0. And then we have this last one right here. And let me make sure I basket the part way before. Okay, great. Okay, and then this last one is negative 2, 2, negative 1. Nice. Okay, so that's a negative 1. This is 4 times 4 is 8. 8 times 2 is 16. 3 times, we know this is going to be negative because that negative. 3 times 2 is 6, or so 0, sorry. That's why it's good to just get rid of it. One was 0. And then a negative is going to be positive. 4 times 3 is 12, times 1 is just 12. We have 0, and then we have 2 negatives, which is positive. 2 times 2 is 4. Oh, and I almost forgot though, because a negative and a negative, but a negative and a negative, 3 negatives is negative. So 2 times 4, that's a positive, and then you have a negative. So then you have this. And so really at this point, I would just make sure you don't make a mistake. 1, 16 plus 12 times 4. There you go. Did I make another mistake, you guys? Did I basket weave the wrong way? Should have been this. Should have been that. 0. Then we have this. Then we'd have. Should have been 2 2s. Yeah, that's right. And then we would have had a. Let me make sure. Goodness, you guys, I'm so sorry. I made a mistake again. Double check my math. 1, negative 2, negative 3, 2, 1, 1, 4, 0, and negative 1. What did I do? Yeah, I made a mistake somewhere, guys. Sorry, I probably I normally don't do the problems like this, so I made a mistake somewhere in my multiplication here. Sorry, you guys. Golly, what did I do here? So, let's see, I'm gonna do it the way I normally do it, you guys. I'm gonna do it the way I normally do it, and then y'all can do the method that you've learned. I'm just gonna do how I normally do this real quick, because in any when you learn how to do it a certain way, it's sometimes hard to go away. Let me make sure I wrote everything down right. 1, -2, 3, 2, 1, 4, 4, 4. Okay, so that is a -1. And then I'm basket weaving like this, so I'm saying 4 times 2 is -8. Oh, I said 16, didn't I, earlier? That's what I did. So in my calculator, I'd be like 4 times, this is so I don't make a mistake, I'd be like 4 times -2 times 4. That gives me a -32. Yeah, that was where my mistake was. And then here would be a 0, and then we minus, and then we have, that is a -12, and then we'd have a -2 times 2 times -1. This would be a 4, and then we'd have a 0. So we'd have that. And so then you'd have -1 minus 32 minus a minus 12 plus 4. There we go, -25. Sorry, you guys. I just sometimes when I deviate from the way I do stuff too, I make mistakes. Okay, so what I did, just so you know, is I do this. They call it a basket weave, where you go like this, and then you weave it out like that, just so you can see what I'm doing, right? And then I multiplied those like that. That's how the direction goes. I know that looks a little confusing, but that's how I've learned it. And then the other way would be this way. You'd go here, and then you'd go on this one and multiply. And that's why they call it a basket weave. So just do it the way you've been taught. Okay. Let's see here. 37. One, 3, 4, -2, -1, -1, 0, 5, and 3. Okay. All right. Again, like I'm gonna try not to. I'll show you how you can write them out to the side, but as you saw, like if I do that, I'm probably gonna make a mistake. So what I'm gonna do is I'm gonna kind of look like that and go, okay, 3 times 1 is 3, that gives me a -3. And then I'm gonna go where I'm looking at this one, and I came out to that guy on the outside, which is just 0. And then I'm using what's left over. 2 times -2 is a -10 times that 4 is a -40. And once again, you can write them out to the side, but I made a mistake like that. So, all right. And so now I'm going to go the other direction, where I'm looking at this diagonal, the opposite direction, and that's subtracted from what's happening. And I say times 0 is going to be 0, right? And then I look at this term, and I come out to the outside, and I look at that one. You get the same thing whenever you multiply it, go out that way. So then we have 3 times -2 is -6. -6 times 3 should be 24. That's a -24. Right? And then what's left over? 5 times 1 is 5, and that's a negative. Okay. So then, to not make a mistake, I'm just going to add those guys in. And we should get I'm so bad at these. Oh my goodness. See, I'm gonna be honest, I've gotten lazy and I've gotten to where I plug these in to a calculator. I'm gonna be completely honest with you guys. So I'm gonna make sure And we should be getting negative 20. Oh my goodness, I'm so sorry. I've gotten to where it should be negative 20. I've just gotten to where I'm so, oh my goodness, guys. Okay, hold on. You should get negative 20. There's a way to plug these into your calculator, and I've just gotten so lazy about them that I'm making mistakes. Make sure I wrote it down right. Okay. All right. So this is probably going to be confusing you guys more than it's helping you because I made so many mistakes here, but let's just do it this way. I'll try not to. All right. We're multiplying down this diagonal. And I think I'm just going to straight up do it in my calculator. So it's because I would go 1 times negative 1 times 3. That gives you your negative 3. And that's that. Or I should probably circle it. Then we get this one, right? That's 0, right? You get this. And you go 4 times negative 2 times 5. So it gives you negative 40. That's what we got. So I don't know where my mistake is so far, but I definitely made one. Okay, there's that. Okay, and now we're subtracting this whole side here. So now, I'm going to use a different color here. And we're going down our diagonal like this. That is a 0. And then we go here, which is if we multiply all those together, it's a negative 5. Oh, I think this is where I made my mistake right here. Because 3 times 3 is 9. 9 times negative 2 is negative 18. That's right, I did. I do a lot of stuff on the calculator, you guys. I'm terrible at kind of. Yeah, there we go. That was my mistake. Okay. Now I'm going to add all those up on my calculator. There we go, negative 20, I swear. All right, you guys. Ooh, I think the marathon math is getting to me. We're almost at 3 hours. Hold on really quick. 3 hours. Okay. Okay, great. Okay. All right, guys, we're almost there. Hang in there. I'm exhausted too. No more math. Stop it. Make it go away. Okay. We're at 37. Okay, 38. We're going to graph. 38 is 2x plus y is equal to 7. Okay, and we're going to graph these, okay? So what we're doing is we want to make it look like a line formula. If I subtract, I moved the 2x over on this side, right? This is the formula for a line, right? Y'all remember y equals mx plus b. That is the equation for a line. Okay, so all we have to do is know how to use it like a tool. So we have our x and our y. And the b is where the graph crosses the y-axis. So I'm going to say 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, my graph looks terrible. 1, 2, 3, 4, 5, 6, 7. Oh, here. All right. I'm going to loop B. This is what happens when you do math for too long. Okay, so we're crossing at positive 7. 1, 2, 3, 4, 5, 6, 7. That's where we're at. And so this is crossing the x-axis. This m that's correlated right here, that's your slope, right? So if I just took that number out and I said my m is equal to this -2, right? Well, every whole number is technically over 1, right? And then remember that we have rise over run idea, right? So that means that we're going down to over 1. So I go 1 down to over 1 down to over 1 kind of idea. And then our line, I'm sorry, my drawing is really terrible, but you're just going down 1 over 2, down 1 over 2. Okay? And that's how you graph that. So if it's not in that form, you have to get it into that form. Okay, so 38. Now we're on 39. 39, okay. 39 is x equals 2. Okay, x equals 2. Yeah, and we're graphing it. So now remember the x's stand up thing, okay? So you simply are going out to 1, 2, and this guy is literally just a vertical line at 2. That would be 2. That's it. So x's stand up, guys. Y's lie down. Okay. All right, 40. Okay, cool. We get this. Y minus 3. All right. So this one, here we go. You got this guy. Y's lie down. You go down here, 1, 2, 3, -3. Guess what? The line. There we go. Cool. There we are. All right. Now we're at 41 for graphing. 41, and we have y is equal to x plus 2 squared minus 4. Okay, we're still good on, we're still recording, good, all right. Okay, so this is, you can tell it's some type of quadratic because it has the square there. They call this the vertex form, and if y'all remember, you have this h, so the vertex or whatever is at this h, k idea, right? So this is our h and this is our k. And so whenever we're getting that vertex, when we extract that out of because technically what you're seeing inside of that, if you were to just take that out of context and think back to synthetic division and you were like dividing by 0, this thing's actually, you're sitting there thinking it's actually equal to 0. So when you move it over, it's -2. That's why the sign changes when you pull this 2 out. So you actually get a -2, and then that's not in the parentheses, so you get a 4. So your vertex is going to be at a -2, 4. And let's see here. And then whenever you're thinking, how do you find where the y intercepts? Remember that whenever you have an interception of the y or the x, you're always setting the other variable equal to 0, right? Because if x is 0, that's at the point where I'm crossing y. If my y is 0, that's where I'm crossing x. So, so if we set our x equal to 0, we can find what y equals. So that's what we're going to do here. If x is 0, that leaves me just with a 2 squared because I got rid of the 0 there, and we have -4. So when we solve this, we get 4 minus 4, which means y equals 0. So that means that we're intercepting y right there at that intersection. And our vertex, so let's do this. So we're gonna go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm just gonna come out like that. Okay. So our vertex we know is, let's move out of the way here. We're on 41. I don't think that was on the sheet here, but all right. So vertex -2, -4, and then our y-interception's here. Okay. Now, whenever we're looking for our x-intercept, y has to equal 0, right? So now I'm going to, am I off camera yet? No. Can I write over? Let's just do it. I'm just going to write it here. So if we have our y equals 0, we're going to solve for x. So we move over 4, right? And then we have x plus 2 is squared. We square both sides. 4 squared is 16, and that takes off this 2 because we squared both sides, right? And now we move over sorry, it's not squared both sides. I was like, I'm making a mistake here. I'm getting tired here. This is what happens when you do stuff in your head. So we want to we don't square, we square roots. Here. And remember, we add that plus or minus. There we go. Okay, so plus or minus square root of 4 is 2. And then we have our, this guy gets lifted off. So then I'm moving my 2 over, so I have a -2 plus or minus 2 equals x, which means that I have, if I take the negatives, -2 and -2 is 4, but if I take -2 and +2, that's 0. So we have a -4 and a 0. So that means that our x is at 1, 2, 3, 4. We have a -4, and we also have a 0. So that means that this guy is looking like that. And I'm just going to make sure that I didn't mess anything up. X plus 2 squared minus 4. Graph this bad boy, and we're looking pretty solid. Okay, and then also don't forget to label your points, okay? So we have a -2 and a -4. Over here is -4, 0. And then right here is 0, 0, right? And that's how we graph those guys out. All right. One, 42, 42, okay. Oh yeah, then we have, okay, so we have y is equal to x minus 2, x plus 4, x minus 5. Okay, awesome. And we are graphing this guy right here. Okay, so before we put stuff together, let's remember that our y-intercept is when x equals 0, right? So if that's the case, then if we're finding our y-intercept, let's just make all these x's zeros, which would just give me right? And so if I multiply those guys together, we go -2, 4, -5, and we'd end up getting y is equal to 40. Sorry, so this will be our intercept. Our y-intercept is there. Okay, and then remember that whenever if we have an x-intercept, is when y equals 0. Okay, so if we put y equal to 0, let me try to over here. So if y is 0, whenever you have these, we've done this before, when you have these types of terms equal to 0, you can set them all equal to 0. Okay? And so then we'd move that over, right? And so these would actually be all of our x-intercepts. Those are all of our x-intercepts. Oh, you know what? Y'all don't graph these. Y'all do just the line. Okay. Okay, so this one's the more important one then, because y'all graph them like this. And so now we know that we have a -4, a 2, and a 5. That's how y'all do these. Okay, and this is technically the x-axis, right? And now we are looking. It's where it crosses, where you have the cross or the touch. Remember that idea? And we had the idea the don't even touch me kind of thing, right? Where evens touch, right? And we're always looking for the exponents here. Like what's going on with these exponents? We'll notice that these are all to the first power, right? Those are all actually to the first power. Those are all to the first power. Evens touch, odds cross, okay? So that means that we are crossing at each one of these guys. That's where we're gonna cross. But how do we know if we start above or below? Well, I sort of, this one kind of answers that question, but let me see, how did y'all do that? How did y'all do above or below? Oh yeah, we're just entering, okay, so just enter a number to the left of 4 into that equation there. So if you put in, that's how y'all do it. So if y'all put in, let's say just -5 here into that equation. So if I went -5 minus 2 times -5 plus 4 times -5 minus 5, that's going to give me a negative number. So that means, let's use blue here, that means that we're starting down here, and that we're gonna cross, and cross, right? And that's how we do these guys. Let's make sure we're right, 42. Beautiful. Okay, cool, so that's how y'all do those. I was about to take y'all down a crazy road. Also, we were about to graph this up and down and left and right. I was like, wait a minute, y'all doesn't do that. Y'all don't do that in this class. Okay. Okay, we're done with that 42. Great. Okay, now we're at 43, home stretch. 43, home stretch. Okay, we have, it says find the distance, slope, midpoint, and the equation. So if we have 3/4, and we have this other point that is -2 minus 6. Okay, so what we're looking at here are 2 points. We've got x1, y1, and we have x2, y2. These are 2 different points, okay? We want to find this, we're trying to build a line, and we know that a line is y equals mx plus b. That's what we want, right? But we also have to have another equation where the slope is y2 minus y1 over x2 minus x1. That's our slope. So we need to put that into this formula where we have our y2 minus y1, and then we have our x2 minus x1 right there. So our slope is a minus 10 over a minus 5. A minus over a minus makes a positive, 5 over that gives us 2. We have a slope of 2. So when we're building the line, we have this equation that's y minus y1 is equal to m onto x minus x1. This is how we build the line. We use that formula. So if we plug that in, y minus our y1 is 4. We got our slope, which is 2. This is our x, and then our x1 is a minus 3. And we just clean it up. So we have y minus 4, 2x, we're distributing, minus 6. And then I'm moving the 4 over, which is a positive 4, which gives you a negative 2 there, right? Because 6, 5, 4, 3, 2, right? And so here is our line right there. Okay, let's make sure we're right. 43. What in the world? Where is that? 43. Okay, cool. Awesome. There we go. I'm trying to double check our answers. You know I made mistakes. Okay. There we go. 43 is good. 43. All right, so 43. Now we're at 44. 44 is the same thing. 44 we have 2, 3, and then we have 2 and a 6. Okay, same deal. We have, this is our x1, y1, because we're just talking about a point. x2, y2, we're just talking about a point. And all those same formulas I just erased, that's what we need to use. So our formula is our y2 minus y1. We have our x2 minus x1. Our slope is 3, and this becomes 0, okay? So what we have is anything divided by 0 is undefined, right? Which means that the slope, an undefined slope, is an x's stand up idea, right? So we have to remember that this undefined slope is a slope that looks like this, is up and down. Well, we know x's stand up, right? Well, if you look here, notice that the x's are the same. So the only way that we can write this formula is x is equal to 2. Because x's stand up. And it makes sense that both points would be where x is 2, right? Because the slope is undefined. It's a vertical slope. So our formula is actually x equals 2. Okay. Now we have 45. And we have a -1, 5, and a 1, 5. It's looking suspicious. I feel like we're trying to. It's y. x2, y2. Okay. We'll start building. We got our slope, which is going to be our y2 minus y1. Well, we already know, I'm not even going to go farther. Look, 5 minus 5 is 0. Anything divided by, well, actually, let's look, because if you have 0 on bottom, that's not what I'm going to do it for the sake of being thorough. That's not going to happen in your class, but you'll see later that that's a thing. So x1 minus a minus 1 right there. So we end up getting 0 over 2. So this slope is a 0 slope. And now if we recall that our y equals mx plus b, well, if our slope is 0, that means that we just have y equals b. Y's lie down. 0 slopes are this way. This is a 0 slope. A zero slope is that way. So, and also notice here, our y's are 5. So it makes sense. If we have a horizontal line, it's going to be going through the same y spot. So our answer here is y is equal to 5. That's our equation there. Don't be confused by those. So whether you have a vertical slope or a horizontal slope, it's either going to be, if it's a vertical slope, it's x equals. If it's a horizontal slope, it's y equals. And that's it. 45. Okay. Now we have 46. And we have x plus 3y equals 2. And we have, x squared minus 2y squared equals to negative 1. Okay. Awesome. All right, so we're here rounding up the end. So this is a system of equations, but both of them are not linear. These are not linear. So what you want to do is, the substitution is best here. We solve for one of these, plug it in here. Okay, so we're going to take, x is already by itself, so I'm just going to move that over. We have 2 minus 3y, just move the y over. I'm plugging it into this x term, right? So we're saying 2 minus 3y squared minus 2y squared equals minus 1. I took this guy, put it here, and I substituted what I found here into here. So this means that there's 2 of those things. Okay, and we're going to try to solve for the y. So I'm going to FOIL this. The first, outside, inside, last thing, where we have 4. This is negative 6y. We have a negative 6y. And then we have a positive 9y squared. Okay? And then we have this minus 2 here equals minus 1. Right? Okay, we're going to combine like terms. We got, that's a like term, that's a like term, that's a like term, that's a like term. I'm going to kind of rearrange them too to move it. So 9, 8, 7, a negative 6 and a negative 6 is a negative 12y, and then we have a plus 4 equals minus 1. I'm going to move that minus 1 over, and we have 7y squared minus 12y for 5 plus 5 equals that. Okay? There's no multiples of 5, so guess what? We're going to end up having to do quadratic. So let's get that in there. So we have a, or here, we have a minus, we're still rolling? Okay. Plus or minus squared minus 4 over 2. Okay. And we have down here, sorry, I'm kind of in the way, but minus 12 for our b's. Our a is a 7 and our c is a 5. Our a is a 7. Okay, there we go. Don't forget that we're looking at our y value right now. Okay, so we have a positive 12, 144, it's positive, 2 negatives are positive. We do have a minus sign in there, yes we do. So I'm gonna use my calculator so I don't make a fool of myself. We have a negative 4 times a 7 times a 5 gives us a negative 140 over, oh yeah, and I forgot, there was a number in front of there, so we could have factored that. We could have done AC method. I'm tired. We're doing this. 14, this equals our y. Okay. So right here, we got our y is equal to 12 plus or minus. If we take 144 minus 140, we get the square root of 4. The square root of 4 is 2. Sorry, I'm kind of jumping. I'm getting ready. I see the finish line. I'm running. Okay, so if we figure this guy out, we have a 12 plus, well, 12 plus 2 is 14. 14 over 14 is 1. A 12 minus 2 is 10. 10 over 14. I can't do that fast in my head, but a 10 over 14 reduces down to a 5/7. 5/7 for our two y's. Let me make sure I didn't make a mistake before we keep going. We're going to be 46. Yes, okay, we're good right now so far. We have our y's. So these are our y's. I'm going to circle them in blue so we don't lose track of them because I'm writing like chicken scratch all over this board at this point. Okay, so we have our y's. Guess what? We can just go back to our original function. All right, here might be even easier because we already have it equal to y. So I'm just going to sub one of those y's in each time and find an x. It makes it easier. So let me do it in blue here. And let me try not to stand in the way. Okay, so we have, actually, you know what, can you see here? We have some space over here. Okay, so x is equal to 2 minus 3, and I'm going to take one of my y's, we're going to put a 1 in there. So we have x is 2 minus 3, x is a negative 1, and we're going to plug in that. And we're going to put in our 5/7 in here. And we're going to say x equal to 2, a minus 15 over 7. And then if I make this make that over 7, that ends up being a 14 over 7 minus 15 over 7, which makes it a negative 1/7. And so we've got these y's, these x's, and now we're going to report our answer. You can see it on here. Okay, cool. So this is we have an x and a y and an x and a y. We kind of have, we're going to have kind of like 2-point answers kind of thing. So the x1, so basically you just match them up, whichever. So I use the 5/7, and it doesn't matter which point, but I use the 5/7 to get, I use the y 5/7 to get the negative 1/7. So I put those together. It doesn't matter which one you group as long as you group them together. And then I used the 1y to find the negative 1x. And so that is our answers there for this guy. Boom. Okay. Where are we at here? 3 hours, geez. Almost, okay. Cool, let's do like a time. All right. Okay, and then I think we're, okay, 47, home stretch. Now this is the last one I'm doing. I think y'all have 3 topics that are off of the, not on the review, which is inverse function, inverse function, compound interest, and then that 7-step graph thing, guys. The video's already so long, I'm not gonna do those. I'm just gonna finish off the review right here. And you'll have to look through your notes for those. Okay, so it's saying we want to expand 2x minus y to the 5th power. I probably helped, but I have to do these more at 2. I didn't realize the video was going to be this long. And we want to, and it says using expand, okay, using the binomial theorem. Oh, it just wants us to expand this. Okay, yeah. So remember, guys, that you need to expand out the triangle here. So Pythagorean is 1, and it's like these. We're adding these two to make that one, and there's always a 1 on the outside. So then, if we add these two together, I get a 3. These two together, I get a 3, and those 1s are always cascading on the outside. If I add these two together, I get a 4. These two together, I get a 6. These two together, I get a 4. And this is a 4. And then 1 on the outside, if I add these two together, I get a 5. These two together, I get a 10, a 10, a 5, and a 1, right? And so these are dictated by the 0th degree, 1st degree, 2nd degree, 3rd degree, 4th degree, 5th degree, okay? It starts with a 0 and you come down, you're just adding on the outside. So now this gives us our coefficients for the expansion of this right here. So what we would do is we would write our expansions, with our leading terms from that row there, where we have this, and this. Okay, kind of writing sloppy, we're close to the end. Here we are, guys. Okay, and then all you're doing is taking the first term and you go 5, 4, 3, 2, 1, 0 for the power. So we're going to put 5, 4, 3, 2, 1, blast off to infinity and beyond. Okay, and now we're going to do the same thing. You can count down from there, or you can count up. So I'm going to go 0, 1, 2, 3, 4, 5. Okay? All right, I'm going to get rid of that real quick. It's bothering me my way. And now we just take our first term and our second terms, and we just fill them out. So we have 2x. Remember, that's a minus y. It goes with it. 2x minus y. 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 Nice. Okay, and then we clean it up. Okay, right now, anything to the 0 power becomes 1. So I'm just going to go ahead and make those are going to become 1s. And now we're going to expand this guy out. We have 2 to the, I'm going to have to use a calculator here. Computer science people are better at that than me. Okay, so 2 to the 5th power is 32 because that 5th power goes to each term. So 2 to the 5th power is 32. X to the 5th power is just x to the 5th power. Okay, so then we have right here, we have 2 to the 4th power. Because this 4 applies to each term, is 16, but 16 times 5 is 80. So we have an 80 x to the 4th. Oh, and don't forget, we do have that negative there. So this will end up being negative y to the 1st power, okay? Then over here, 2 to the 3rd power, 2 times 2 is 4, 4 times 2 is 8, 8 times 10 is 80. So we have this 80 x to the 3rd power, but y with the negative is positive. So we get that guy right there. Then here, we're coming over, working our way this way. All right, so I'm actually going to take care of the negative because it's annoying. So anything to the 3rd power, -1 to the 3rd power is going to be negative. So we know a negative is going to be chilling there. And we know that y is going to be to the 3rd power. Okay, so let's take care of this. So 2 to the 4th power, 2 to the 2nd power is 4. 4 times 10 is 40. And then we'd have x to the 2nd power. Okay, let me make sure I'm not making mistakes here. Okay, here we are. All right, and now we know this is plus because a negative to an even power is always positive. So we know 2 to the 1 is just that. So 2 times 5 is 10 to the x. this becomes y to the 4th power, and then over here, this just becomes, because a negative 1 to the 5th power is negative, and that's negative 5, 1 right there. And that is how you expand. Bang. And that is the final. Okay, let me make sure that that's right. It's just right here. 32, negative, positive, 40, 10, negative. And we did it, you guys. Okay, that is 3.5, right on the money, right when I looked at it, 3.5 hours. Let's go.